All right, we still have 1, 2, 3, 4, 5, 6. We got 6 VPSs that are unclaimed so far. So, I mean, just write your name on the spreadsheet. Yeah, before somebody else does. I sent it in the Telegram group. Everyone's in the Telegram group, right? All right, I'll give people, so it's right here. It's this, if you join the Telegram group, it's called t.me/btcpp Nix Berlin. That'll get you into the group. And, oh, people are claiming things. Oh, okay, we got 2 left. Who wants them? All right, I can write your name. What's your name? Star? Star gets that one. All right. We got one more there. Anonymous Tiger. Everything else is spoken for. All right, yeah, so node number 12 is... I have to hand it to Joe for being right justified. Yeah, Joe is right justified. He's righteous. Yeah, there's one right here that is not taken yet. What is it? J-A-Y. All right, Jay gets this one. All right, let me know, are you going to do some kind of... All right, yeah. Xfrog, are we good? Let me try one more thing. Okay. We're still updating. All right. Hello, everyone. Welcome to part 2 of day 1 of Bitcoin++ nix-edition, Berlin. My name is Chris Guida. I am a developer. Currently, I have a grant from OpenSats to work on a Core Lightning plugin, and also just kind of general merchant acceptance and developer experience, especially in the Lightning ecosystem. Just upgrading all of your nodes right now. All right, so I guess we can do this. All right, so this is going to be slightly different. This is going to be a hands-on workshop. I'm sorry, I wanted to have enough VPSs for everyone to do this workshop, but I learned like very recently that DigitalOcean gives you a limit of 25 droplets. So 25 of you, 19 of you plus me will be able to do this tutorial. If you haven't gotten your name on the spreadsheet, just team up with somebody who has. I think, so hopefully this is going to work. I tested it, so, and it's Nix, so, it's not the sort of thing where like it works on my machine but like not your machine. Also, all of the machines are exactly the same, so hopefully it will just work. All right, so yeah, what I wanted to do is I wanted to showcase the power of Nix and also Nix Bitcoin and also a little thing called MutinyNet, which is a custom Bitcoin signet, which has 30-second block times instead of what you're used to, which is 10-minute block times. And instead of like 20 minutes and then 5 minutes and then 30 minutes and then like 1 minute and then 1 minute and then 1 minute, it's like 30 seconds, 30 seconds, 30 seconds. It's very predictable and fun. Okay, so if you haven't already, please go to this tutorial on GitHub, github.com/chrisguida/deploying your first NixOS machine. It looks like this. Anybody who signed up on the spreadsheet and is not in this tutorial yet, just raise your hand and we'll just wait for you to do that. We also, okay, so you guys aren't in yet? Yeah, so github.com/chrisguida/deploying your first NixOS machine. Yeah. Are you in Telegram? Okay. Sorry, I guess I should have made this a shorter URL. I guess I can do like a bit.ly or something. Is that a thing? Yeah, if you go to my username, it's like, click on repositories. It's the first one, because I just created it. All right, yeah, and then go to .tutorial. I made this in Replit because that's what I'm used to. And then click on this first page, which is 01 intro. All right, is anybody not in the tutorial yet? All right, we're good to go. All right, I'm still modifying the machines. All right, the machines are done being modified. So hopefully that means that everybody has super high powered droplets. All right, 96 gigs, 600. All right, yeah, we're good. All right, I think that's all. Let's see. Yeah, we're going to make a MutinyNet Lightning node, and we're going to send some Lightning transactions. We're going to do this in the next, hopefully, 15, 20, 30 minutes. So here we go. Let's go for it. All right, so the first thing that you're going to do, here's a little intro. Yeah, Nix Bitcoin, MutinyNet, I mentioned those. All right, next go to the init page. I'm going to do this with you, so hopefully we'll find any problems. So we're going to SSH into our box. All right, SSH. We're going to replace the part that says your IP with your IP. I'm this one, so nobody steal my box. Oops. Whoops. Yep. Oh, yeah. Good idea.
There you go.
All right, hopefully that's big enough. All right, the password is BTCPP. Or it should be. All right. Wait, node 2. Oh, no. Wait a minute. Okay, sorry. That's somebody else's node. Don't log into somebody else's node. Don't do this in production, guys. All right, BTCPP. There we go. Now this is node 1. All right. So now what you're going to do is you're going to go back to the instructions, and you're going to do NixOS generate config with sudo. And of course, your sudo password is BTCPP. All right, it's going to give you this warning about how it's not going to overwrite configuration.nix, which is fine because we're deleting it anyway. That's the next step. Yes?
For those of us who pegged in by shouting out, could you go back to the spreadsheet so we can get
Oh, yes. Okay, yes. Star. Yes, let me make this larger. Yeah, star, right? You are 162.243.187.227. All right, everybody else has their IP address, right? All right, does anybody not have an IP address? All right, because you need one. All right, we're editing our configuration.nix, as it says in here. So first you have to rm it, and then you have to vim it. Then we're going to copy this. So this is kind of a basic Nix config. We're importing the DigitalOcean base config. We're fixing a couple of problems that I found in testing. We're pegging to state version 2311. We're enabling Nix commands and Nix flakes. We're adding ourselves as a user. Here's one thing that will help this be slightly less crazy is we can comment out the password and we can paste in our SSH key. So if you have an SSH key, feel free to do this. So grab our SSH key and paste this into our here. Okay, and then we're going to save. And then we're going to do our first NixOS rebuild switch. So it's going to build some stuff, going to build the configuration, build some derivations. And then it's going to restart stuff. Then hopefully, if you added your SSH key, you can log out, and you can log back in, and it will just log you in, and now nobody can log in with BTCPP. This actually might be an issue for sudo, now that I'm thinking about it. So this might not work. All right, cool. So that's the first step. Is everybody with me? No, all right. Where are you stuck, or are you just still going? Still going. All right, cool. So you may not want to add your SSH key. That might screw up sudo for your user. I didn't actually test that. So yeah. Oh, you know what you can do? You can do sudo without. Does somebody know this? Sudo without password. Let me.
Well, for NixOS, you have to add a sudo as an option. That.
Oh, you know what? That's interesting. Okay. Wait a minute.
No, he removed the password, so it's accepting enter.
Sudo I BTCPP. Okay, somehow that's still the password, even though I commented it out. Great. All right. Well, so either that didn't block password SSH, or yeah, something is happening with the configuration. I'm not sure. But anyway, all right. Rate, please. The people who's still going, who's still stuck. All right. Anybody else? Anybody else stuck? Ready to move on? Ready to build some Bitcoin nodes? All right. I'm gonna get some people started early on this Bitcoin building, because this is the step that takes the longest. Although, are you guys in the tutorial? Star? Okay, so you guys have the instructions and everything? Okay. Okay, cool. Cool. Yeah. All right, I'm gonna do the Bitcoin part, because this is the part that takes the longest. It's just building Bitcoin from scratch. So we're gonna edit this thing called flake.nix, and this is gonna add a flake to our system. It's gonna run our configuration as a flake. We're gonna copy this in. And what this is doing is basically just, it's grabbing a fork that I made of a branch of Nix Bitcoin that Eric Arfstead made, that has MutinyNet instead of mainnet. So if you want to run mainnet, you'll have to use a different config. So that's this master thing. The other thing that this does is it contains mempool. So that's in the bonus section if we get there. So hopefully we do. We're going to save that. We're also going to re-edit our configuration.nix, and we're going to add a Bitcoin section. Let's see, NixOS configuration.nix. And we're just going to go to the bottom and hit O to add a new line and paste that in. We're also going to do this generate secrets thing and our operator name. This is going to tell Nix Bitcoin to generate the passwords and stuff that we need for our Bitcoin stuff. And it's going to set our Bitcoiner user to the operator. And then, okay, we're going to want to add our Bitcoiner user to the Bitcoin group. So we're going to add this word Bitcoin to the extra groups line. So oops. Bitcoin. Okay, cool. Excellent. Thank you. It happens. Nix would catch that at build time, though, so it's fine. Excellent. All right, so did I do this? Okay, so I added myself to the Bitcoin group. All right, and then, oh, this is kind of an optional step, but it's going to allow your node to be reachable over the peer-to-peer network. So we want to do this. We're going to add the firewall. And this is just going to open port 8333 in our firewall, and then we're going to do another sudo NixOS rebuild. Switch. And when we do this, it's, oh, whoops, I'm sorry. I forgot, you have to build this specific output from the flake. There are other ways to do this, but, all right, so this is why we need really, really fast machines for this workshop, because this is gonna build my fork of Bitcoin D, which is a slight modification to the Mutiny Net Bitcoin D, which is a slight modification to Bitcoin Core. We are playing with fake money, so you don't have to worry about it. You can trust me. We're not, this is Signet coins, so if you want to look at the patch, of course, you can just go into this flake and you can look what I did. Okay, this is going to take a few minutes while that's building. Is anybody stuck, or does anybody have any questions so far? Is anybody like really bored? Am I going like too slow? Too fast?
Does anybody want an explanation of what Signet is and why it's different than testnet and regtest and the main chain?
Yeah, that's a good question. Would you like to explain that, or should I explain it?
It's entirely up to you.
You sound like you want to explain it.
All right. So for Bitcoiners out there, your real money is on the main blockchain. The Bitcoin Core has built-in support for two types of testing. One is called testnet, which has some really significant disadvantages in that the way it issues new coinage is flaky. And so using it for testing has been problematic for years. Then there's also regtest, which basically just does locally issued tokens on localhost. So Signet is a way of bridging the gap between the trade-offs of running testnet, where the coins are generated from what are called faucets, but they're done irregularly and the block intervals are too short. So Signet has a different way of generating those, its own different types of faucets using signatures, thus Signet as a test network. And it has a different block cadence, which is better for most types of testing. So Mutiny Net has their own Signet, and that's what he's talking about when he says he's building a Bitcoin Core with support for Signet and specifically for the Mutiny Net settings.
Yeah, and actually the feature that the Mutiny Net fork adds is the ability for a custom block time. So as Jim said, testnet gives you like a bunch of blocks all at once, and then it gives you like no blocks for like 4 hours, and this is a nightmare to test things on, and it's especially a nightmare to do something like this workshop where we have to get done in like half an hour. So actually this workshop would not have been possible without Mutiny Net. So thanks, Mutiny guys. All right, yeah, thank you so much for that explanation. That was great. All right, and then of course, so even the regular Signet has 10-minute block times. And so if we were to open a Lightning channel, then we'd have to wait 10 minutes for it to confirm, unless we were doing zero confirmation channels, which is another thing. Okay, so while this is building, it should be just a few more minutes, but we'll take advantage of the fact that that's building to edit. I guess we'll need another SSH Bitcoiner. We'll need another tab for this. What's my IP? What is my IP? It's this one, right? Should be. let's just grab it from here. All right, so we're going to edit our config again. Oh, never mind. All right, so we're done building Bitcoin D. And all right, so let's finish up this step actually before we do the correlating thing. So since we added our user to a new group, we have to log in and log out and log back in. And that will add us to the new group. All right, so now we should be able to do, let's go back to Bitcoin. We should be able to do Bitcoin CLI, get info, and what we should see is we should see that our node is running. It's actually almost done syncing. No, sorry, it's not. Okay, so this is 30,000 blocks out of 471. Can somebody get him a microphone? I can't hear him.
If I'm the only guy who was lost at configuration nix and adding lines, don't bother, but I'm not sure I'm the only guy.
You mean with how to insert things into Vim?
No, I'm aware of VI since the 80s. Sorry, but boomer, yes.
Okay. Most people aren't, so.
The tutorial tells me to add 2 lines, nix Bitcoin generates secrets equals true, and the second line. If I put it below the file of configuration nix, I feel like hurting a syntax check.
Yes, okay, so I'm sorry, I guess I kind of glossed over that. So you do need to put that inside the last curly brace. So not at the end of the file, so it's going to look like this. What is it? Etsy, NixOS. So you have this services.bitcoind, and then there's an open curly brace here. And then there's a closed curly brace down here. And then you want those 2 options to go somewhere outside of that curly brace, but not outside of that curly brace at the bottom. Does that make sense? Can I see your error, actually? I'm just going to.
And if you don't mind, I'll comment. When I was learning Nix, this is the thing that frustrated me more than anything else, is most of the documentation tells you to add this or that. It does not give you very good clues as to precisely where it's appropriate in their structure to do this. So it would be very nice if the NixOS people could actually put some good comments in their default configurations that kind of tells you what to call each section or nesting in the default file. So at least they can, in the doc, say, in the thing that's commented, #, foobar colon, you can put it anywhere within those set of braces. But that doesn't exist now, so this is going to be the thing you'll probably find most frustrating, is everything you're told to put in or change, you have to either find it or you have to figure out where it's valid to put it. Gets me every time.
So one thing we're fixing is, I guess it wasn't clear in the tutorial, you're adding to the configuration.nix file. You're not creating a new configuration.nix file for each step. We're sort of incrementally building this configuration.nix that has everything in it. All right, there's a question over here. Bitcoin CLI is not on your pad. Oh, okay.
No, this is the one above. This one.
Grub.
This guy D's.
Ooh, okay.
This is pretty fundamental. This is my thing. So
Did you copy and paste, or did you
yeah, just copy and paste it.
scroll to the top? Interesting. Let me see that error again. Okay.
I'm not finding that.
Failed to get block ID.
Like this is a label. Seems pretty low level. Maybe in the hardware configuration.
Did you do the sudo NixOS generate config?
Yeah, I did, but
And did it give you a hardware configuration.nix file? Yeah,
should be here now.
hardware configuration.nix, yeah. Yep, yeah, you got it.
This label, yeah, it's just an apt.
Yeah. Yeah. So sorry if things. That's the one problem with this workshop. If things go wrong, it might just be.
But they're all the same machines?
Yeah. I mean, they're all exactly the same. So if you follow this tutorial, if you didn't miss any of the steps, then
We go one, we do it once over.
yeah. Let me just see it one more time. All right.
And I can build it again. So the next rebuild is correct now.
Yep. Error. Failed to get block ID information. Yeah, I'm sorry. Just join up with somebody else, and we'll fix your machine after. Yeah. Okay. All right. All right. Yeah. So we only have like 20 or 30 minutes left for this. So sorry. I was hoping this would work for everyone, but it seems like there's like subtle things where like if you don't do exactly how they are in the tutorial, it's hard for me to go back and figure out what exactly you did differently. So it should work the same for everybody. Okay, so where was I? All right, so we got Bitcoin D running. We're syncing MutinyNet. Just put this here. Okay, so MutinyNet should sync pretty fast. Who hasn't gotten this far, other than this guy over here, who has an error that I can't figure out right now? Is everybody else? Everybody else has built Bitcoin D and has synced it, and it's syncing or has already synced to MutinyNet? Raise your hand if you've synced to MutinyNet already, like me. So 471. Has anybody synced MutinyNet yet? Okay, this guy, 1, 2, 3, 4. All right, maybe 4 or 5 people. All right, well, we have like 19 people, so I guess some people are not synced yet. RPC credential error. Oh no. One sec. All right. Any other errors that we have here? The RPC thing? Yeah, so just log out and log back in after you add that Bitcoin group to the extra groups section there. Yeah, for some reason, NixOS requires you to, well, no, I guess Linux requires you to, whenever you change your users' groups, you have to log that session out and log it back in. I think there's a way to do it in session, but I don't remember what it is.
New group.
New group.
The new group command will start a new shell with all of your new groups added to your,
Cool, good to know.
or optionally you can give it a group name you specifically want to be.
All right, how much more time do we have?
10 minutes.
Oh, God. Okay, let's do, sorry, okay. All right, now we're going to do CLN. So we're starting our Lightning node. Sudo, all right, I'll fix everybody's errors after this. Sorry, guys, I thought this was going to be faster. BTCPP. All right, at the end of our config, we're adding Core Lightning. Then we are adding the C Lightning group to our user. So extra config, extra groups. We're gonna put our user in the C Lightning group, and then we're adding 9735 to our firewall. 9735, and then we're switching. And this is, I think, oops. I think this is going to build Core Lightning as well. This should be a lot faster because Core Lightning is much faster to build than Bitcoin D. All right, is anybody stuck? Anybody stuck anywhere? Was that a hand? Did I see a hand? Okay, over there? What's the error message? All right, one sec. All right, we're still building Core Lightning. All right. Let's see. All right, so has anybody built Core Lightning yet? Raise your hand if you've built Core Lightning and you're done with that part. All right, this guy's done. All right, reloading user units. All right, now we're going to log out and log back in so that we can get it into the C Lightning group. And then we're going to run lightning CLI, get info, and this is going to show us our Lightning node. So I'm hopping Trinity because Core Lightning makes up random aliases, which are fun. Oh, if your block height is like really low, then that probably means that you turned on Core Lightning before your Bitcoin node synced. And in that case, you can just nuke your Lightning node and start over, and then it should just immediately sync to the end. All right, and then since we only have like 5 more minutes, I'm going to show you how to actually use MutinyNet. So we're going to go to faucet.mutinynet.com. We're going to grab a new address from our Lightning node. We're going to ask the MutinyNet faucet to throw us some Satoshis. Make it rain. Let's see, let's get 10 million, because why not? And then we can go to mempool.space. It's going to appear in the mempool. In 30 seconds, it should confirm. So we'll just wait for that. And there we go. And that's my favorite thing about MutinyNet is it's just every 30 seconds. It's so nice. All right. OK, so now if we do list funds, we should see our money here, our 10 million sats that we just got for free. And then, OK, then what we can do is we can start opening channels, post your URI. So this is your, oops, I'm sorry. So you're going to go get info. So you're going to build this string, which is your URI, and an @sign, and your IP address, which is, oops, IP space A. This thing. And then 9735 for the port. You can just post that in Telegram. And then people can connect to you using Lightning Connect. If somebody would like to send me their Lightning URI on Telegram, I will connect to you. And then just yell it out once you do, because I'm going to look at some other stuff. Connect to some peers. Okay. All right. Anybody? Anybody got a URI? Put it in Telegram. I guess you could put it on the spreadsheet. Yeah, that works. All right, this is an IP address. Oh, okay, here we go. Ruben, you win the contest. All right. I'm going to connect to you, so lightning, CLI, connect. All right, we have a connection. Then, because I have 10 million sats and I'm generous, actually, I'm not generous, I'm not giving you any sats, I'm just opening a channel to you. Let's see, CLN. Okay. So then you're going to open a channel with fun channel. I put this in this command, fun channel. What do I got here? 1 million. Okay, so I'm opening a million sat channel to this guy. All right, we now have a 1 million sat channel. Ruben, let's see. All right, we're dual opening. Hell yeah. I forgot I added that, yeah. We could actually do a dual open. I don't think we have time for that, but maybe after the workshop. All right, and then generate an invoice if you haven't already, and give me an invoice, and I'll send you an invoice. I will also post an invoice. So just run this command. This will make an invoice for 1,000 sats. It'll give you a thing called a bolt 11. You're going to copy this. Whoops. And you're going to paste it in Telegram. And then somebody can pay you. Let's see, lightning, CLI, list. I think it's that. All right, so this one is unpaid. So anybody who has 1,000 sats and would like to pay this invoice, please do so. So it'll say paid. How much more time do I have, Lisa?
3 minutes.
3 minutes. All right, cool. We are actually going to get to the end of this, the non-bonus part of the workshop. All right, yeah, so you guys should all be able to connect to each other because you have your ports open and everybody's public. And let's just see if this gets paid. Shout it out when you pay it, by the way, so I can, so we can finish this, so we can be finished. Yeah, so just, this is the pay. So you just do lightning CLI pay and then this invoice. All right. Or somebody send me an invoice and I will pay it. Syntax error, all right. What do we got? Yeah, so you need to add the core lightning section, and then you have to do the switch with the etc NixOS flake.nix, and then hash Berlin BTCPP immediate. What's up? Yeah, I don't know what's going on here. Address. Sorry, which this person that posted this error, what section is that? Oh, plugins. Okay, that's core lightning. Address 000. That part should work. That part is tested. All right. Somebody hasn't paid my invoice yet. All right, anybody, just run this command. I'll just post the command. you can do list funds. So to see your balance, Lightning CLI list funds. Unfortunately, that won't tell you the summary of all your balance, but actually you can do summary, because I think I installed, I did. See this? Plugins.summary.enable. So you can do that, and that'll tell you your balance as well. Let's see, has anyone paid this yet? Oh no, it's still not paid. Is anybody able to run this command? It looks like a bunch of people have nodes. I'm the only one that, okay, I've created a channel with, yeah. Well, that's going to show the whole MutiNet, though. Yeah. Ah, that's true. That's true. Okay, somebody send me, yeah, somebody send me their pub key. Actually, Ruben, I'll just key send you. Key send. What's that? You paid. All right. Hey, there it is. It's paid. All right. We did it, guys. All right, so yeah, I have a bunch of more sections in here that we didn't get to, unfortunately, but I guess I'll leave these VPSs up for a bit, and you guys can play with them. You can add RTL, which will give you a fancy front end, so you don't have to use the command line. You can have Fulcrum, which will allow you to use Sparrow with Mutiny Wallet. Also mempool, it'll let you do address lookups, and then of course you can add mempool, like I said, because I'm using a fork of Nix Bitcoin that has mempool. Please do this step before I destroy your node, which will be like in an hour or two, I guess, probably. When's the coffee break? At 3. Okay, I will destroy your nodes after the coffee break. Yeah. So please, if you would like to keep your Mutiny sats, which you don't really have to, but it just makes things cleaner. Here's how you can withdraw them to your address, or you can donate them to me. And then I have some end credits. So special thanks to Nix Bitcoin, Mutiny Wallet, this guy named Justinus, who made a great tutorial, HashiCorp and Terraform, Morph, Lisa for showing me the tutorial, and then my meetup group, which is called Bitcoin Lightning GDL, which is Guadalajara. They were awesome and helped me test this. So that's all, folks. Thank you.
Let's get another round of applause for Chris. That was amazing. Really good. Thank you. Cool. So while you guys are all figuring out how to pay each other Mutiny sats, our next talk is gonna be Christian. Christian's headed up to the front. Christian's gonna talk about how simplicity and Nix work together really well. So Christian, if you wanna come on up and go ahead and get set up. Waiting for...
Yeah, this was like a toy Nix Bitcoin setup. It was just basically to get your hands dirty with NixOS, or with Nix Bitcoin. Nix Bitcoin, as Jonas said, is like designed with security in mind, and so you'll definitely want to like read all their documentation so you can figure out how to make an actually secure node instead of the sort of very insecure node that we made today. Thanks, everyone.
Oh no. I think I'll just do it like this. My presentation mode is slightly broken, I know.
I think this works, huh? Yes, this works.
Should I start? All right. So I'm also Chris. I'm Christian Level from Blogs and Research. This is going to be more theoretical. It's going to be a talk about how we use Nix in our research at Blogs and Research. So it's called Simplicity plus Nix equals Love, which I think is a good title. I came up with the title, and then I had to come up with the content, which was the hard part. All right, so what do we do? What do I do? What do we do at Blogs and Research? At Blogs and Research, we do cutting-edge Bitcoin research, as the name implies. In particular, we work on Simplicity, which is a universal smart contract language for Bitcoin and for Liquid that Russell O'Connor, who was mentioned here before, came up with, created, and has maintained. He has maintained this for almost 10 years now. So it's a pretty old project, which is still growing and which is still not obsolete, which is a good thing. Like I said, it has universal smart contracting capabilities. So with this, you can enable all conceivable smart contracts that we want on Bitcoin. And it uses a verifiable software toolchain. So it's written in so-called verifiable C, and it has a formal specification. So we can make sure that what we write is actually correct according to our specification. And we are working on a Liquid integration right now. And this is going to be the next big step. And then after that, we will focus more on Bitcoin itself. So that's what we do. That's what we do in 4 bullet points. I'll talk about first how our project Simplicity benefits from Nix. And then after that, I will talk about how Simplicity lends itself to the Nix infrastructure, how Simplicity works particularly well for Nix. So Simplicity is a pretty complex project. So we have at least 4 code bases. We have C, we have Rust, we have Haskell, and we have Coq. This is the thanks to the French for this name. And so this is the formal verification part. It's the Coq theorem prover allows us to formally verify our code. So the specifications are written in Coq, and then we can connect this, check this against the C code, which is the consensus relevant code base. So all these code bases fulfill certain roles, and we have to build them, we have to test them, we have to maintain them. It's pretty complicated, and separate people work on these projects, so that's complexity. We also use vendoring. So this means, for instance, there is C code which is copied to the Rust crate for FFI, for foreign function interface. There also is Haskell code which generates C code, and there is Haskell code that generates Rust code, so additional complexity. We run elements D. So this is the elements is the open source component of Liquid, and elements D is the Bitcoin D for Liquid, basically. And we use the patched version, which runs Simplicity. And if you have ever compiled Bitcoin D or elements D, you know this is not an easy feat, especially if it's a patched version. So making sure this all works is complicated. And then we also have a tech report, which is not always up to date. It's written in TextMax, which is the weirdest LaTeX format I know. And honestly, I could not build it without Nix. So after Russell graciously wrote a config, I was finally able to build this locally, which is really useful. We also have a complex CI, so we want to test all of this, that what we write works. So we have a minimum supported Rust version for our Rust crates. And so this means that we can compile our Rust crates with this minimum supported Rust version. So it doesn't compile only with the latest version, but also with this previous version. I think right now I don't know, we increased it recently. I think it might be 1.58 or something. So it's not 1.70, it's 1.58 or something. So it's a few years ago. And making sure this works is, so this is not a feature that is really supported by Cargo, which is the building tool for Rust. So making sure this works is also complicated. Again, the vendoring, so if someone updates the vendored code, we have to make sure someone copied the right code. And because every time we copy something, there's a potential for malware. We run fuzzers, so we test our code against random inputs that are created by the fuzzer, and the fuzzer tries to make our program crash. And if it fails, then we conclude our program is pretty good. So this must work, and also anything that uses Bitcoin nodes or elements nodes and complicated tests, we need to make sure they run in the same way on all computers. So if the bugs need to be reproducible, if there's any bug, anything that uses more than one node is a complex scenario that we need to somehow encapsulate in a configuration file, and somehow we need to be able to run this multiple times in the same way. And also our team is complex, so we are on different continents. We run different computers, different architectures, different operating systems. The software must just work. So if I have a bug in Europe on my NixOS, whatever, on this laptop, then Russell O'Connor in Canada must be able to reproduce this bug, or Andrew Polstra. We live in different countries, and we cannot just go to each other and help each other out if there's a bug, right? So this is really important that the software works. How Nix helps? Nix makes sure that our dependencies are complete, so we actually have to think about what is required to make our tests or our binaries work. How can we compile them? How can we run them? Because if we don't specify something, if we forget something, there will be an error for us as well, right? So it cannot happen that we install something on our local system, forget about it, everything works, and then we ship the software, and then our colleague or even a customer, they run it, and they don't have the dependency, and then there's a bug. This, with Nix, the error is on your computer, on the developer's computer, and you can catch it and you can fix it. We have one-liner installations. I will show you something in a minute. So running these tests, building these binaries are just one-liners, even though we run really complicated software. So this is, like I said, it's cutting-edge research, and which means it's complicated software, multiple code bases, and still we can run it in one-liners, which is amazing. We can reproduce our builds, and most importantly, we can reproduce bugs. So if there's a bug, there's always some kind of bug, we can reproduce it, and we can put this in a PR or on a messenger somewhere, and we can try to fix it. I want to show you a particularly bad example. It's a good example, but it shows you how bad it is to not use Nix. So if you want to do the formal verification, you can do that. So you can go to our simplicity repo, will be a link later, and you can run this command. And this will build the formally the cock code, which is a list of definitions of theorems, and it will execute the proofs, which will basically say the simplicity is well defined, and the runtime has certain properties and so on, and the programs have certain properties. And if you run all of this, you have basically formally verified simplicity on your local machine with one command. Sure, it will take some time, but it's just one command. Let's do this manually, just setting it up, right? So just setting it up. First of all, you have to install the OPIM package manager, because this is this OCaml. So this is this really weird package manager. You have to install it. I don't even have the installation here. You have to initialize it. You have to set up your shell for it. Then you have to install cock, but you have to install a specific version, 8.15. Don't install the latest version. Mad break. And then you have to install a patched version of the verified software toolchain from Princeton University. So the verified software toolchain enables us to formally verify C code and the simplicity C code, and also, as far as I know, libsecp is written in this specific verifiable C style, which is a subset of C, and you can write theorems about it. So there's a formal COG equivalent to each program, to each C program, and we can prove that the program is correct, that it meets a certain specification. But because we are special in simplicity, we have to install patches. So we have to do something, some SHA business, some hash business, custom SHA implementations. I don't know what this does, but it's complicated. And this, you might need to configure it. So you have to actually know what these programs, what these lines do. I don't. And then you have to go to the COG the directory. You have to execute the COG makefile, which creates a makefile, and then you have to execute the makefile, double make. And then after this, I think you have verified simplicity. Okay, so this is one line, and this is more than one line. So I recommend you do the one-liner, because there's less potential for error. And you find all of these lines in our repository as well. Okay. So the takeaways are, you can run the latest Bitcoin research on your machine with Nix, and it will just work. The results that we have are reproducible, so if it runs on our machine, it also runs on your machine, and it just speeds up our development. So without Nix, we could not develop at this speed. With a small team that works on simplicity, and without Nix, everything would just be slower. So thanks, Nix. This is part one, the main part. And then I was thinking simplicity is also very, well, let's say amenable to Nix, or it's like, it works well for Nix because it's a functional language. So let's take a look at that. Why does it work for our project, and how can you know that it works well, that Nix could work for your project especially well? How can you change your project to make it work better with Nix? There are a couple of points that make Nix better, or that make this workflow better. So a functional language like simplicity or functional programs work really well. A functional program means, among other things, that this program always returns the same outputs if you give it the same inputs. So it's deterministic. It runs, so in this case, it's a simplicity program, or the simplicity interpreter. It runs in an isolated runtime. So we know exactly what the runtime consists of, what the parameters are for a simplicity program. And then inside that environment, the simplicity program always runs in the same way, and always the same way. If there's a bug, there will always be the same bug. If there's no bug, there will always be no bug. We can verify the outputs, we can verify the inputs. All the side effects are well defined. A side effect is when the program like modifies the outside world, outside of the environment. So maybe a file is written, or a file is read, or something that is in the outside world. And simplicity actually almost never has, like, it almost does no side effects. Like, the only side effect it does is the programs might fail. Like, there might be an assertion in the program that fails. So like a signature check can fail. That's a side effect. Or it runs it reads from the current transaction. So it reads a signature hash from the transaction. That's also a side effect. That's a side effect that simplicity can have. If your program, your project has more side effect, if it like reads crazy things from the network or from the file system, then obviously it will not work as well with Nix, because all of this is impure, and if the outside world is different, if the things you read or write fail or are different, then the outcome will also be different. And like I said, simplicity is verifiable, so this just means that the points above actually are true. So we actually verify that simplicity is deterministic, has an isolated runtime, and has well-defined side effects. And also the runtime is small, so simplicity, the name kind of comes from the fact that simplicity is the smallest set of features you need to do what it does, and what it does is universal smart contracting on Bitcoin. So it's not nothing, but it's very little code for what it does. And little code means small attack surface, few things that can go wrong. And like I said, it's also verified, so the probability that we have a bug is relatively low. It also means that we can write exhaustive tests, because the number of possibilities is so low. For instance, we have 9 combinators, so 9 basic functions that simplicity consists of. We can test these 9 things. With Bitcoin script, I don't know if someone knows the number, I don't, but we have many more opcodes, maybe 50, maybe 100 opcodes. Just testing 100 takes much longer than testing 9. And if you test if you do combinations of opcodes, then this explodes, whereas with 9, that's much simpler. You also have few dependencies, so again, fewer things that can go wrong. So simplicity is minimal, and if there's a small code base, then Nix has an easier job making sure that everything runs and the configuration files are short and so on. And the formal verification is one of the main selling points of simplicity. So what we can do is we can write a formal specification for the runtime and also for a program, and specify what does the runtime need to do, what is the execution, what is a correct execution. And then if I write a program, I want to realize a certain spending condition, and I can formally verify that the spending condition is correctly encoded in the program. And then it runs on the correct runtime, so it actually works. So yeah, correct runtime, correct programs. We can even, and this is obviously a lot of work, but it's a lot of work, but the runtime for sure, the runtime runs all the programs, which means it manages millions or billions of dollars worth of Bitcoin. So making sure this works is worth it in my estimation. And then for the programs, you need to formally verify each program if you want. This is a lot of work, but again, the programs are often reused. So for instance, a Lightning HTLC is reused. If we verify it once, then we have the benefit every time we use it, and we only have the cost once. And then we have the guarantees that formal verification gives us. And we could go further. This is like far future stuff, but we could even, so imagine simplicity is somehow merged or it's used, and we want to make sure we don't break it. So it's correct, but we don't want to break it. Every time we make a commit or a PR, we could write a formal proof that the commit is correct or doesn't break the correctness. Sorry. And we can run the proofs locally, and running the proofs locally means you need a setup. And this means Nix is pretty good, because Nix enables you to just execute all of this in one line instead of doing this long stuff that I showed you, because you need to do this long stuff to do the stuff on the slide. Okay? So really, the true power of formal verification comes from the fact that everybody can run it with a minimum setup, with like a really easy setup with a one-line setup. So the takeaways are, if your project is like functional, so if it is well-defined, what it reads and what it needs, if it's deterministic, then it lends itself to Nix. Then Nix, which is also functional and pure, will work really well with it. Otherwise, the two will kind of battle each other. Less code can be better tested. So if the goal is to make sure to have correct software, having like a small code base is obviously good. And a small code base also means, like I said, a shorter configuration file and fewer things that can go wrong. Verified code has fewer bugs, so if we can verify our code, we will find bugs, and there will be bugs. Whereas if after the verification, it's a very low chance that we find bugs. And then we have the benefits of Nix, which makes sure that the deployment is really easy, and we actually deploy correct code, which is good. So it's easy to set up, and it runs correctly. you find our research on GitHub. So we also have blog posts and so on. I felt I just put the GitHub link. So you find the simplicity repo, the Rust simplicity repo, other kinds of repos. So you can check this out, github.com/blockstreamresearch. And that's it. Thank you for your time. Happy to take questions.
Anyone? Anyone?
Just a quick comment. I think why the both work so well together is that you already need some gigabrains to understand simplicity. So if you already have them, then why not do it all in Nix?
Yeah, maybe I should have written, have Russell O'Connor on your team. Makes it much easier to deploy Nix, yeah. Yeah. Apparently he was the person who introduced Blockstream to Nix. So that helps, yeah. Or having at least someone like write the configuration once, make sure it works, and then it works for everybody, right?
Anyone else?
Who should they mention it to?
Oh, you should. So if you find a glitch in simplicity, I mean, there are different code bases, right? So you can open an issue. I'm sure, I mean, I will definitely make sure that we will have a bounty program once it's like properly deployed, because if anybody has a bounty program, it should be us. Like we are saying formal verification, complete absence of bugs. So we should have a bounty program. We don't have that right now. There are certain code bases that are not consensus critical. So the only critical is the C and the coq. And for instance, the Rust and the Haskell code bases are much more malleable, and there could be more bugs. But if you have anything for now, it would be amazing if you could open an issue. Or hold on to it until we have the bounty program. Yeah, that could work.
Hold on to it until they deploy it.
Sure. So is there a GitHub that's publicly accessible yet for Simplicity's code base?
Yes, for Simplicity's database?
Or its code base.
Yes, there is.
So bugs could be reported through GitHub's bug tracking system for now.
Yeah, so it's on GitHub. It's here, Blockstream Research / simplicity. And as you can see, there are some issues. So you can report it here. For instance, the stop code needs to be updated. That's the C, Haskell, and coq code base. They're all in the same repo, and the Rust code base lives in Rust simplicity. Yeah.
Cool. Thanks, Chris.
We need to
All right, next up, we're going to have Calais talking about ecash in the wild. Great. Thanks.
I'll just deconnect this thing. All right.
While Callie's setting up, we're going to have one more talk, and then we'll have a short break for coffee, etc. Time for you to ask Chris Guida any last questions about MutinyNet before he deletes them. Awesome. I'm excited about this. Cool. All right, Kelly. Whenever you're ready, yeah?
Okay. So I'll start. Thanks for everyone joining. I feel a little bit like an imposter here because I'm new to Nix. I haven't used it, but I'm very much looking forward to also making use of it in the context of the talk that I'm going to present here. But still, I hope you will be entertained or learn something new today with this talk. I'm going to talk about Cashew, which is a Chromium ecash system for Bitcoin. In short, it is a way how we build custodial Bitcoin services that are unable to track their users and offer an excellent level of privacy. And this will be the main focus of this talk today. We've been taking this concept that was originally invented in the 80s, Chromium ecash, and really bringing it back, bringing it to today's world and combining it with Bitcoin and doing all sorts of crazy experiments with it that I want to show you today. So the main theme of this project is basically summarized by blinding custody. There are two main risks in using custodial systems today that all of us Bitcoiners know of. And the first one is the custodial risk, which is the ability of the custodian to run away with the money. Cashew does not address this problem. I refer to Fediment, which is an excellent Chromium ecash project that also builds on Bitcoin to minimize the custodial risk. However, today I want to talk about the second risk of custodial systems, which is complete transparency of the user's activity when you use a custodial system. So the problem, basically a very simple problem definition, is that a custodian, in order to provide services, needs to know all your activity, your balances, and the payments in and out of a system. And an alternative approach for a custodial system is using Chromium ecash instead of using classical ones. So this is the beautiful image that Nifty made for my avatar for this talk. We use custodians everywhere in our daily lives, and this poses a huge problem to our privacy, especially for smaller amounts, which we tend to be okay with using custodians. For example, you would have some Satoshis on a wallet of Satoshi or something like that because you want to benefit from the properties of having an online wallet. But since you pay your coffee with that and your magazines online and whatever you read and consume, it leaves arguably a very important or very critical trace of your activities. So some examples of custodial systems that I use or that everyone knows. Here you can see Stacker News. I'm an avid user of Stacker News. You can post about Bitcoin and earn Satoshis. You can see my balance up there, and whenever I make a post, someone can upvote my post, and I get some Satoshis for it. Obviously, I'm using Albi, which makes it very easy to interface with the Lightning Network in a browser. It's a custodial system where the service provider also knows what you're doing, which websites you're visiting probably, or at least which invoices you're paying, so the destination of these invoices as well. Wallet of Satoshi, I already mentioned it. It's a must mention because it's the largest Lightning service provider, user-facing service provider that we have today. Looking at Nostr itself, and this also fuels the use of custodial systems. We can see that when you count the number of zaps that people do, above 90% of zaps are from custodial wallets or to custodial wallets, which is understandable because you want something that is online all the time, and not many people go through the hurdle of setting up a Lightning node to receive a couple of Satoshis on Nostr. Obviously, now exiting the Bitcoin world, if we go into fiat world, everything is custodial except for the cash in your pocket. So there is no way to interface fiat non-custodially. This also extends to services that we consume on the web. Here, as an example, it's a standard, paywall or subscription services. You could also argue these are kind of custodial, even if they don't feel like, because you make a payment and then you expect a service in return over a course of a month, for example, which puts you in some kind of a trust relationship, although there is not so much trust in losing your money and them running away with that. Similar for streaming services where you pay these monthly fees. So all of these systems that I just showed you work in the same way. And this is how, and it's very easy to understand. If you have worked with these ledger-based systems, you already know this. We have Alice and Carol, both are two users of the system, and we have Bob in the middle. This is the custodian. And when Alice wants to send Bitcoin now to Carol, what she says to Bob is, please, Bob, here's my ID. Here's the ID of my counterparty. Can you please move 1 BTC to Carol? And then the custodian here needs to basically check whether you both have a valid user ID, and then pops up a database in which all the past transactions are in. So you can see some couple of transactions already happened, and Alice has enough money, right? We check first, Alice has enough money, and then add 2 new entries to this ledger, just subtracting from the sender, adding to the receiver, and then we ping Carol, and Carol says, nice, I just received some Bitcoin. So all this is to simply explain that this system is built purposefully because we don't know of any, this specific system of any other way how to build it without the service provider really knowing everything about what you do. So Chaumian eCash works completely differently, and we will start again with the same actors here. We have Alice and Carol, and Bob is now our mint, or the custodian. We call it sometimes the mint in the Chaumian eCash context. You could think of it as a bank or whatever service provider you want. And now if Alice wants to send a 1 BTC to Carol, instead of pinging the mint directly, she pings Carol directly. And this can happen over any communication medium. It could be a chat or a QR code or whatever. And basically, Alice takes some piece of data. Now, Chaumian eCash is represented as a piece of data on your device. It takes it from your hard disk and then sends it over this communication medium to Carol. Now, you will think, this can be double spent. This is just digital data. I can copy and paste it and send it again from Alice to Dave, for example. In order to prevent that, the transaction is not yet complete. We have to first send this note to Bob, and then Bob does the following. First of all, it checks the signature on that object on the eCash and says, yes, this is actually correctly signed, and then destroys this eCash by putting it onto a ledger. Now, this is the only database that we need to carry. It's a list of seen eCash nodes, and if the node wasn't seen yet, then it can create a new green eCash node, as you can see here, and send it back to Carol. And now the transaction is complete. So basically, we have done this dance from Alice to Carol, and then from Carol to Bob, and then back from Bob to Carol. Now, this was an eCash transaction. The properties of this eCash system that I will be explaining a little bit further along this talk is, first of all, the entire process that I just described is completely untraceable if you, excluding any network level observations. That means that the mint itself does not know who was the previous owner of this eCash when it received it, for example, when it got the pink one and reissued the green one. So it makes it untraceable. eCash is also a bearer token in its original sense, meaning that the data is not just an access to money, it is the money. So moving the data from one person to another means moving the money. And that also means that you can put the data into another communication protocol and send money over that protocol. I will give some exotic examples on that later. Different from Lightning, I've been working a lot on the Lightning space. In the Lightning system, you have a pull-based UX where you first create an invoice and then someone can pay that, except if you build something around that. eCash is different from that. You basically take eCash and throw it at the receiver, and if the receiver catches it, then the payment is almost complete, excluding the double spending path that you also need to go. And lastly, eCash is programmable. This is heavily inspired by how Bitcoin itself works. Turns out you can program money, and this enables very, very cool things, also with eCash that I will be touching on later. So, Cashew is an eCash project. How does Cashew work? There are a couple of different Lightning wallets that people have built. You can check out enuts.cash, which is a very advanced iOS and Android wallet, minibits.cash. Both of these are native apps, but there are also nutstash and Cashew.me that are progressive web apps that you can run in your browser and install on your device, and which makes it feel like an actual app. So, there are many different implementations that people have built so far in the year of the existence of this project. I will just mention a bunch of mints that people have built. So we have the nutshell and LNbits integration, so you can run this Chromium ecash mint in your LNbits. And also want to mention 2 Rust implementations that are also working as mints. There are many more wallets that people have built. This is because devs have come up with libraries, and turns out libraries are just the absolute amplifier of development and low time preference way of building things. And you can see that the list is arguably longer than the previous one. I also have this group called integrations, where we really want to experiment more on how to put this Chromium ecash system into existing apps. 2 of my favorite Nostr apps, Snort and Amethyst, both have implemented some parsing for tokens, and you can just press one button, and then it gets, if you see a Cashew token, you press one button, and it gets deducted to your Lightning wallet, for example. And I also want to mention a category maybe called new use cases or some exotic use cases, things that we can now achieve because we actually work with a bare UX token. And so Cashew and Proxnode are 2 examples that I will be giving, and Cuts and Post as well. This is to summarize basically the idea of taking the ecash and putting it into a data package for payment of a service, something that I will be showing later as well. So just to quickly go over milestones, because so this project has been around for 1 year, and people have joined building it, and we have achieved some remarkable steps in the meantime, I would say, in the short time. First of all, it's fully integrated with Bitcoin Lightning, so you can interface the Bitcoin network using the Lightning network. We have achieved also generating the ecash deterministically, which means that previously ecash was known for this problem of you lose your wallet and the money is gone, or you have to make an update with every single state change in your wallet, similar to very old Bitcoin wallets. But it turns out you can also generate your ecash deterministically, similar to how we generate Bitcoin addresses. So this has been also implemented in a few Cashew applications. We've been working around with programmable ecash with spending conditions. Here as 2 examples, pay to public key and multisig. We are working on a proof of liability scheme. Ecash is also notoriously known for not being auditable, so anything that makes it more auditable gives more trust to the system. And since this is basically a trust-based system, it's important to be able to prove to the public or to the users of a mint that the mint has not printed ecash out of thin air, and this is what the proof of liabilities scheme is about. So you can talk to me later if you're interested in particular. We are also working on receiver offline transactions. This also works. You can lock ecash to a specific receiver, and if the receiver is offline, they can take the ecash, and there will be no double spending possible because it was locked ecash. So this is very interesting and attractive also for cases where the receiver either does not have internet, or you want to just avoid talking to the internet because you want payments that are extremely fast. Finally, we have a couple of libraries and integrations and implementations that people have built. All right, so here this is the gist of my talk. Actually, you can, if you forget everything what I say, this is what you should remember, because this is the actual lesson, is how blind signatures work. And blind signatures are a cryptographic primitive, and if you understand it once, it just clicks in your brain and feels awesome, and you can use it in your life. So, a blind signature, a definition of a blind signature is very simple. So, it says, a blind signature allows you to sign a message that you have never seen, and to verify that your signature once the message is revealed to you. So you can think of it as someone basically, closing their eyes, making a signature on a document, never seeing the document, which would be, reckless, obviously. But once someone comes back with a document and you see the signature, then you can recognize it's your own. This is similar how blind signatures work. Another popular example that people use to explain blind signatures, a physical example that everyone can kind of imagine, is a carbon paper envelope example. So basically you have a carbon paper envelope. This is the, the paper where you press through and then it leaves the markings on the paper below. Imagine a carbon paper envelope, and then you take a contract and you put that contract into that carbon paper envelope, you close the envelope and send it to the bank. And then a bank takes a pen and signs the outside of this envelope without opening it up, and then sends back the signed envelope to you. And you can open the envelope because it was encryption, right? And take out the contract and you see a signature there. So that's also a blind signature. How does it really work? So we have Alice and Bob. Alice is the user, Bob is the bank. Alice creates a secret. Now this is the contract in my previous example. It's just a random string, random data, and then blinds it. So basically encrypts it with a secret that only she knows. So Alice encrypts that data and sends it over to Bob. Bob takes his cryptographic pen and makes a signature there and sends you back the signed envelope, basically. And then since you were the one who encrypted this message, you're the only one who can decrypt the signature. And what you get at the end is this message that Bob has never seen and a signature that Bob can verify. And this is what we do when we spend ecash. So here you can see this icon reappear that I showed previously in a couple of slides before as representation of ecash. This is the ecash. So the secret that I've generated and the signature together is ecash. This is the money. So when you spend the money, you present this tuple to Bob, and Bob can just do the signature check and say, yep, this is okay, and burn the ecash and give you something in return. So this is blind signatures. The most important property of all this, and the reason why this is a blinded scheme, is because we want to unlink operations. And if you want to take even a more bird's eye view of this, you can think of the blind signature schemes used in ecash systems as a way to unlink operations. So formally you would have, in a classical ledger-based system, you would have these events, plus 1 BTC for Alice, minus 1 BTC for Carol, and so on and so forth. But these all depend on what has happened before. If you want to have these operations unlinked from each other, statistically uncorrelatable, then you can use blind signatures. And this is basically what it achieves in ecash. But why I'm putting an emphasis on this idea is once it makes sense in your brain, then you can use the same operation to build authentication systems that are blind, to build, I don't know, some voucher system, or whatever, your supermarket might give you some customer credits or whatever you want to design, with the point being that it remains fully anonymous for the users. Okay, so we have just explained how a Chromium ecash system works, and you can think of it as a universe inside, and people are playing around with ecash. But what are these ecash tokens worth? Obviously, they're not worth anything because it doesn't cost money to print them. However, when you embed such a system into an already existing economical framework, such as the Bitcoin system, you can actually start making use of them and make real economic transactions. And this is why we implemented Cashew and integrated into the Lightning Network. So there are two main operations in Cashew interfacing with Lightning. The first one is the endpoint called /mint. Basically, this is how tokens are generated. And in order to generate an ecash token for, let's say, 100 sats, you need to pay an invoice for 100 sats. So it says, hey, Mint, I would like to generate some ecash. And then Mint says, okay, pay me this Lightning invoice. Basically, you pay the Mint. And then once you make that payment, the Mint generates, you do this back and forth, you send the blinded secret to the Mint signs it, sends you back the money. So this is now you have ecash that lives in your hard drive, the Mint has never seen that ecash, and you can later spend it. And when you want to later spend it, again, you want to now take your ecash and pay someone on Lightning, you basically do the reverse, you say, hey, can you please pay this invoice for me, dear Mint, and then the Mint says, okay, I have a Lightning node, I pay this invoice for you if you give me ecash for it. So this is how we can generate ecash and destroy ecash. I should mention also, I mean, this looks a bit artificial, this relationship between Alice and Bob, but when you open a Cashew app that feels like a Lightning wallet, this is what's happening in the background. So you can imagine a user doesn't even need to see anything about the ecash happening. It's just they only see the Lightning stuff. So it feels exactly like Wallet of Satoshi, but in the background, there is no user accounts or anything. It's just this sending around and signing and unblinding ecash and so on.
But it is not that terribly different from United States normal money at this point. Somebody works for a company. The company, Alice, tells the bank, pay this person. They put his money in the person's account.
Yes, but it's blinded, yeah. I mean, your bank account could use ecash as well, but
But the $5 bill that is allegedly played to me, it
Has a serial number on it, but nobody is going to look at that serial number. It is effectively most people consider the $5 bill sitting in their pocket to be anonymized because nobody is looking at serial number 227650 and Pennsylvania Mint or
yeah,
whatever.
you're right. So ecash has similar properties to physical cash. So it's basically similar properties, I would say. Yeah, that's true. Okay, so we've talked about Lightning and how it works in the context of a single mint, right? And you can think of this one mint now with a couple of users here. And we've also seen how users can send each other ecash. So when users want to communicate with users, they can use whatever protocol they want. They could do it over Nostr, QR codes, Telegram, whatever. We've also seen how a mint communicates with the external world, which is over Lightning. Now, you can think of obviously, so Cashew is not built, we don't want a monolith that just a big bank that runs the entire system, but the idea is making everyone be able to run the system very, very easily. So, and that's also where Nix comes in. So you can think of a second mint with their own users in their own application or some website that offers something and they have their own users. But some users might have accounts in multiple mints, as you can see. Or no, I shouldn't say accounts, but ecash. Have ecash from multiple mints. If you don't have that and you would like to, you're a user at this green mint and you want to pay a user at the pink mint, the only thing that you can do is to go over Lightning. And this is how basically the mints communicate between each other. They use Lightning as a settlement layer in between. And I've lent, I think, this expression, Lightning, the connecting tissue in this Cashew ecosystem from Nifty 9. All right, so let's get into more advanced stuff. Programmable ecash. So the most basic spending condition for ecash is you cannot spend me twice, right? That's so basic that you don't mention it. But we can attach more complex spending conditions to ecash. You can think of it very similar to Bitcoin UTXOs, where you attach a lock to a UTXO and only someone who can unlock that lock can spend it again. You can similarly attach a lock to ecash. One example that I will be giving is pay to public key. So pay to public key in Cashew works the following. First of all, Carol, the receiving user, needs to generate a public key and a private key that she keeps secret, but the public key she can share with the world. That is something like a Bitcoin address. And the Bitcoin address, or this public key now, this ecash address, is represented as this green lock. So you send the green lock to someone else who would want to send you money. This is QR code, for example. And then Alice can take her ecash that she takes from her wallet. This is ordinary pink ecash, and attaches this lock to that ecash. She does that by destroying the pink one once and then getting back one that has a lock attached. Interestingly, the mint doesn't know that this happened because everything is blinded. Then Carol takes the locked ecash and sends it, Alice takes the locked ecash and sends it to Carol, and Carol still needs to, take out the lock in order to do whatever she wants with it. And for that, she sends it once to Bob. And now Bob says, okay, this is special ecash. It has a lock attached to it. I want a signature for you to spend it. And Carol needs to provide the signature. Here you can see an equivalent of a simple Bitcoin script. We even implemented Bitcoin script, but it doesn't matter. It's just some lock and a witness, and that's it. If you can provide the witness, I can take off the lock, basically, and you can spend the ecash. And in return, I give you a green one. Now the transaction is complete again. So this is interesting because with this, you can do a couple of things that were not possible with the naive scheme. First of all, you can post this ecash publicly, right? Previously, whoever finds the ecash can spend the ecash. anyone can spend. Now you can attach a lock to the ecash, which means you could post it publicly, for example, on Nostr, and everyone could see that someone has paid someone else, but only the receiver can actually spend the money. What I found even more intriguing is the receiver can remain offline. So again, just to reiterate, if you're offline, I know your address, I can attach a lock to ecash, and while you're offline, I can just post it somewhere. You, as a receiver, only need to see the ecash, and you know it cannot be double spent. You don't even have to go back to the mint and take off the lock and get a green one or whatever. You can defer that into the future as much as you like, because if you see the ecash that has your lock attached to it and the signature of the mint is valid, the transaction is complete. And this enables some crazy fast payments, and something that I also have a slide of later. Oh yeah, so this is just what I explained. By pre-locking ecash to receiver, you can basically send money as fast as the data travels in the network. One other thing that we've been working on and implemented are hash time lock contracts, HTLCs, which is a primitive that we use on Lightning. And basically, the idea is either you unlock ecash using pre-image of a hash, or you wait long enough so that the sender can redeem it back. That's the time lock. And with HTLCs in ecash, you can do almost all the things that you can also do with Lightning, and you can do it with Lightning together. So you can have atomic swaps of ecash with ecash to ecash, or you can have an atomic swap with Lightning to ecash and ecash to Lightning. So we could be two Cashew users, and you don't have a Lightning node, I have a Lightning node. I could offer you to make a Lightning payment for you if you give me ecash in return, and this happens atomically, so no one can rug anyone else, if both of us trust the mint, right? So this is a way to get rid of the trust two users need to have towards each other by delegating our trust to the mint. Some very exotic ideas that has been not worked on, but I just want to mention it as food for thought, is that this, in a situation where you can handle HTLCs with ecash, some people were even theorizing about taking shortcuts onto the Lightning network. You can think of routing an HTLC on Lightning and going over a shortcut, through a ecash system. If the sender knows the path that is possible, I could take ecash and forward it to the other ecash user, then continues back on the Lightning network. Everyone would still have the agreed upon trust relationships they have. Most of the Lightning users don't need any trust, but those in the middle can, if they trust the mint, they can create these shortcuts in the Lightning network. So this is also one way to improve the connectivity inside the Lightning network. All right, so at the end, I want to mention a couple of advancements that we have done with this simple protocol that we called Cashew. This is an attribution to the headers in the HTTP protocol that you can add to your requests. Basically, what we're trying to do, like a couple of other projects as well, is to unearth the lost and forgotten error code, HTTP 402, payment required. And I really think this one vibes really well with ecash because of its UX bearer token nature. So you can think of a client and a server. Server offers some service. Client says, hey, get API. And then the server says, no, I want money for that request. Give me some ecash in return. Now what the client does is take some ecash inside the GET request of the HTTP, of the HTTP request, put the ecash into the header. And this Cashew project that we've built is basically a collection of reverse proxies or middlewares that can be put between the client and the server. And this reverse proxy just takes out the ecash from the HTTP header, checks whether it's valid, yes or no, and then the server replies with their service. Most importantly, the server here does not need a list of users, does not need to track their accounts, does not even know which user corresponds to which request, and also doesn't know that two requests from the same user came from the same user, except if the user uses a unique IP or other network-related tracking. That was me. So here's an example of what one of the Cashew devs has built. This is called Proxnut. You can find it on proxnut.com, which is a paywall that was implemented with this idea. So this is almost perfectly anonymous paywalls that you can build that work with Lightning. So this is a website, it's a demo site. You can see 3 buttons. All of them, they cost money to press the buttons. You want to get content behind the button. And here on the upper right, you see very small, it's a Cashew wallet. It's a little bit of JavaScript that you can import into your front end. And then it's just a Cashew wallet that lives there. So you can see me trying to press the buttons, and then the server says no. And I need some nuts. So I click on the Cashew wallet here, and you see it's 0 nuts. Press top up. This creates a Lightning invoice that I now take my phone and scan this with my Lightning wallet. And a couple seconds later, I have now 20 Satoshis in that wallet. And as you can see, once I press these buttons that cost money, it deducts ecash from my wallet that you see up there, pays the server responds with the content. Yeah, better don't ask why. All right, to conclude, this is my last slide. I'm sorry for being already half a minute too late, but to conclude my presentation, I want to give one more application that we're working on, also thinking about how we can implement this in other solutions. I call it here onion routed ecash because it really blows my mind. So all of us know Tor. Some of you also might know Katzenpost or mixnets in general. Basically, you can think of it like Tor on steroids. One problem with these services is that they would like to, often these services would like to have some kind of a payment system inside to incentivize people hosting these nodes and so on. But which payment system is, first, private enough, and second, fast enough to allow for that? And there's almost nothing that I can think of, especially blockchain-based currencies. So the idea is, as in the previous slides, put the ecash payment inside the request itself, but the idea squared here is the package itself is an onion, so we can put multiple payments inside one single package. So you have this situation. The client is on the left, and the server is here on the right, and there are multiple onion routers in the middle. So what the client does is generates an onion. This is the package, the data package that you will be sending around in the network, and then put some money into each layer of the onion. So, the next one opens up the onion, sees some money, takes out the money, okay, and then sends it further to the next one. Opens the onion, sees some money, okay, and sends it to the next one until the actual data receives the recipient. So these are some of the things that we are working on. If you are interested, you can join our ecash hack day. This is a satellite event to this conference, ecashhackday.github.io. It's on Sunday. Please register if you want to come. And thank you for your attention. May the nut be with you. And encrypt your backups.
Cool. Well, we have time for one question.
One question.
For minting, is that currently not atomic? So when I do the mint, so I do the Lightning payment and then I receive the ecash back, that's currently not atomic in the protocol.
Yes. So currently the minting process relies on the same trust assumptions as the rest. So you trust the mint to actually give you blind signatures back. But if another user would be in an exchange, basically, then you could do it atomically. So you can have this relationship with another user, similar to what I explained as well. But right now, it's only the mint doing it. Yeah. I think that's it. Thank you for your attention.
Thanks, Kelly. Thanks, y'all. We've got about a 20-25 minute break. So we'll be back here at, let's say, 3:35 or so. So 20 minutes. Oh, okay. Cool. Yeah, that is kind of weird. Linux is almost there. Not quite. Okay, so let me...
Is there a micro USB jobby doodah around?
What?
A converter, micro USB converter.
We were borrowing sticks. Let me see if I can find it. Do you need it?
Yes, please. Oh no, I don't. Maybe that's why it didn't work when I tried it last time. It's like I've got a HDMI port, dumbass.
This is a window, baby. Like a window guy. It is, isn't it? Okay, it's a window machine.
No.
No, it looks like a...
Did it?
Fine.
Ugh.
Don't... It's
Oh
alright.
yeah, there we are. Nice.
Looks good. You're not mirrored, is that okay? Oh, that's funny. This is super anonymous, yeah. Great, thank you. Appreciate that, yeah. I'm tired today.
Yeah. Always running on fumes of these things, aren't we? We sent the POSs out.
Looks good.
Oh, cool.
This is the UI on...
Yeah.
Cool. Great. Amazing.
Shall I unplug it and you can plug yours in and do your thing?
I mean, I've got Linux also, so yeah, I'm on Ubuntu. Are you an Arch or something, Ben?
Yeah, this is Arch, yeah. Because my Ubuntu machine died, so I've like put the Arch on this thing and... Yeah.
There's something about the driver. We're trying to do screen capture off the HDMI, so it feeds it both to screen capture.
Oh, that's weird.
As well as the, yeah, it's okay.
Oh, I just don't want to dox myself, that's good. Is there anything, I don't think there's anything I can do. Is it, you have to do some magic. Yeah.
It's fine. Yeah, we're just doing it as a backup screen recording. It's nice to be able to get it off the screen directly, but it looks really good on the internet. I was checking. No, it's really nice. Yeah, it looks really good. Yeah. Oh, it's Peter.
Are you going to go to Brazil again?
Hello? Hey everyone, this is your minute warning. We're gonna get started in about 60 seconds. So get your last snack, find your seat, and then we'll turn it over to Ben. Cool. All right. If you guys could give it up for Ben Ark, he's going to be talking about LNbits and Nix. Cool.
Hello, hello. So I'm going to talk about LNbits and Nix and something of our Nix journey, which we've had over the past couple of years. I'm going to cover LNbits and what it is, just for those of you who don't know. I'm sure most of you probably know the project. But LNbits is just a simple wallet account system which you can install on your Lightning node, and it adds a lot of functionality, so you can use the functionality in your stack if you're providing a service which requires Lightning payments and people to have accounts. And we also have this amazing extension framework as well, where you can extend your LNbits in any direction which is relevant to you, your customers, your project, whatever. But I've been very interested in Nix since I heard about it from my friend Matt over here, who's going to be doing a talk after me. So LNbits core is a UI which you can engage with, and it's a Lightning wallet which you can have on your desktop or on your phone, and you can use. Other people can create accounts if you want them to create accounts on your LNbits install and use it just as a progressive web app Lightning wallet. You are a custodian, you are the open node, you are the LNpay. But it's also a very powerful API. One of the solutions LNbits fixed really early on was I was developing things for the Lightning Network, like hardware devices and some software projects. And every time I made a new project, I'd have to make multiple versions of it. I'd have to have like an LND version, a C Lightning version, and a LNpay version, OpenNodePay version, and et cetera, et cetera. And I really just wanted like a common API I could like develop for. So LNbits sits on a bunch of different funding sources, and then it just gives a nice common API which you can develop for. So if for whatever reason you want to switch from LND to Core Lightning, or Core Lightning to LND or Eclair, it doesn't mean that you have to like start rewriting your stack. You can just like swap out the node which sits underneath LNbits. So it has a powerful API. It's great for projects and services, but it's also great just for a user who just wants to play around with sort of cutting edge, bleeding edge functionality. Because we have this extension framework where people contribute extensions, it means that when something new happens in our Bitcoin land, like Nostar or something, then pretty quickly people will develop extensions which people can make use of. So, but like with the ecash, for example, like Khalid created the Cashew extension, which made it really easy for people to spin up mints, and then also like have some wallet functionality as well. And then also just gets a project out there in the wild, because people already have their LNbits installed on their Umbrel or their Raspberry Blitz, and it means that they can just, very easily like one-click install an extension and then have all that extra functionality. And then each one of those extensions also comes with its own API, which means that if you have LNbits in your stack and then someone creates a new, one-click Nostar relay extension, then if you want, you can then offer that to your customers, your project, or whatever, or just your friends and family or whoever you're running your LNbits for. So it's a really powerful, useful project. More and more people are sort of making use of it and enjoying using it. When we first started to try and Nixify LNbits, so I spoke to Matt. I met Matt in
EMF camp in the UK, and he nix-pilled me pretty quick. I think we orange-pilled him with the Bitcoin bear tap, and then he nix-pilled me. And I was like, okay, cool, like, we really want to nixify LNbits. But then in Matt's own words, it was a great application, but shit software. So when it comes to reproducible builds, obviously, you need it to be good software. So we were very application-driven from the beginning, and it's almost like we needed direction. I mean, obviously, the software project was improving, and it was catching up with the application to become a great software as well as a great application. But we needed kind of, I don't know, like some sort of direction. So we nixified LNbits, and in that process, like, we had a bunch of different virtual environments we were using, like Venv and pipenv, and Matt was like, no, you need to use poetry. If you're going to nixify your project, you need to use poetry, you need to do this, you need to do that. And just that process made our project better, and it gave us kind of the pursuit of reproducibility then made our project better. But within about 2 commits, we'd like undone all of Matt's great work because we weren't quite ready for our project to be nixified. It still needed a lot of changes and structural changes. So for example, with LNbits originally, we had like, a dozen extensions, and when you install the software, you would just have the extensions, they're all packaged in. And we knew that we had to extrapolate and pull those extensions out. So they would, when you went to install an extension, would actually go and fetch the extension and install it into your software. But we hadn't quite got there at that time. So there's a lot of breaking changes we needed to do, and we just weren't quite ready. But actually, that pursuit of trying to nixify the project was a really good motivation for us to switch to poetry and then make some changes to the project to make it more reproducible. I've got a little video on the project here. This is just an animation of over the years of us working on the project and all the contributions. And it's, I can't remember the name of the project which generates this video, but you just give it the GitHub repo, and then you can see all the contributions being made. And it's quite cool because you can kind of see all our extensions being built over here, and they're all packaged in with the software. And then we get to a certain point, and I think actually this is probably where I met Matt and he nixified it, and then we broke it. And then in a moment, we should see all those extensions pop out as we pull them out of the core software, and then we actually have them being able to be installed into the software project. So any second now, hopefully we'll get a pop. Come on. So it's pretty messy, as you can see. But there we go, boom. So as a modular project, we needed all that stuff kind of pulled out, and then people would actually install them into the project. Okay, and then this is where we kind of are now. Bitcoin needs Nix because of XYZ. Okay, so what is XYZ? And like I say, the pursuit of Nix for us made our software project better. But then what is reproducibility in Bitcoin? I think personally that a money node, it has to be a reproducible build. If I'm running a money node, I don't want it to change the way it functions just by the hardware in which I'm running it on and the way in which I've installed it. And it should be a dedicated system as well. So I shouldn't be running a whole bunch of different applications and software on a computer which is also running a money node. I want it to be a separate thing which is secure and locked down and has access to a limited amount of packages. As I said, the pursuit of reproducibility is the quality standard. So where we're at the point in our software project now is Matt's nixified it again. And now we're at the point where the software is no longer shit, it's actually good, and the application is also great. So we can maintain our nixified project, and then that is our quality standard. As long as we develop and it works on Nix, then everything else should work great. And then also I was thinking about like banking and social scalability. So yesterday I was trying to install LNbits with Nix, and I was on a train and I had really bad internet, and the internet kept coming in and out. But it just magically worked. And then I was talking to Matt about it, and he said, it kind of acts a lot like BitTorrent in that way, like it just kind of picks up where it left off. And it's if you're in a country where you have limited access to internet or whatever, actually that's a really good property of having something running on Nix for when you install it, and that's also part of its reproducibility. And the next part, which we're going to look at now, is how far can we push this? So yes, we've nixified LNbits. We can make it easy to install on Nix Bitcoin, but I'm an idiot, and I don't want to have to faff around with a config file, which I'll probably break, And you know, most people in the world, not like the great good people in this room, are idiots, and we need UIs with buttons and toggle switches and all those sorts of things like that. This picture, by the way, is when I put NixOS on my desktop computer, and then I turned it on, and then I had just this green screen, and I was like, what is this thing? And then I had to actually open up my computer and pop out the little battery cell from my CMOS board, CMOS, thank you, my CMOS board, which I've never had to do before to a computer, in order to you know, bring my computer back to life again. I sent that to a friend of mine to say, yeah, this is me trying to install Nix right now. So, LNbits as a UI for Nix Bitcoin. And this is the juicy bit, isn't it? So we have LNbits running. I've got it running just locally on my machine here. There's been a really good contribution for our own testing, which is a nice red testing environment for LNbits where we can spin up a bunch of nodes and then test LNbits. And I've just got that running and funding my LNbits now, so this is running on Core Lightning on RegTest. Over the past year, I want to be able to run a node and then, well, I want to be able to run LNbits, and I just want to be able to operate solely through the UI. I don't want to have to fiddle around with command line. I don't have to go into config files and end files and things. So we've built in this really nice managed server menu for the admin, where you can select the funding source you want it to attach to. You can have an allow ban list for users. You've got some server stuff you can change, some properties for your server. You can add lists of different extensions which you could install on your LNbits. You can limit the, you can have a default currency. So say if someone's running their LNbits in Europe or you're running it for them, like a cafe or something, and you want them to be able to see an exchange rate, you can add that. And then we've also got this great security part of the admin setup for managing our server, where we can have a block list for IPs. We can limit requests. We have a kill switch you can opt into. So if we find some critical bug, we can send a signal. Well, you poll a repo, and then if you poll it and it says, yeah, this critical bug's been found, it will just shut down your LNbits so no one steals your funds. And then we have this great watchdog thing which will look at your funds on your node and your funds on your LNbits, and if they become too far out of sync, it will just also turn off your LNbits. So all this has been built out of necessity. We've got a nice little way of looking at our server logs here. And then you can also fiddle around with the themes and stuff and change the look and style of your LNbits. We try and make it as customizable as possible. But as you saw when we go to funding here, we've got these couple of toggle buttons here. So in the most recent release of LNbits, we've got this new node management UI. Because I was fed up having to launch RTL and going into RTL, which I found was quite slow and didn't work so well on our server. So we had this amazing PR by Jack Starr, where he's added this node management UI for LND and Core Lightning as well. So I can manage my node now through my LNbits as well, and I can create channels, and I can look at peers and stuff. And I just think it's really slick and simple and easy to follow, and I've got a dashboard. There's even a public page, which I don't know how to open, but there is a public page which you can give to people, and they can see your node details if you want to, if you want them to have access to that. So that's great. So now I can manage my node in LNbits. I have all this crazy functionality through my extension framework, where I've got access to all these different extensions which do all these funky things, such as points of sale and video streaming, extension where you can put a QR code on the screen and people pay you and an animation happens for content creators. And we've got a bunch of Nostar extensions for one-click relays. We've got Nostar Market, which is a project which came out of LNbits, which is a completely Nostar native peer-to-peer market, which solves the problem of peer-to-peer markets. So we've got all these great extensions. We've got a wallet account system. I can manage my node through the UI. But now, because the nature of Nix Bitcoin is it's a bunch of module config files, right? So if you think about node solutions, if you think about your Umbrel or your MyNode or whatever, they've got these different ways of tackling the problem of you installing software which you might want to have access to on your node. And I think Nix Bitcoin is the answer, really. But for people like me, I need a UI. So how far can we push it? So we've started building this
management UI, which simply goes through all the modules in the Nix Bitcoin repo. And then you can see here the different modules. And then it parses the config files and then just turns them into a UI, which I can go through, and then I can just change the variables inside the UI. It's still a little bit complicated, but it's less complicated than actually changing the config file myself. And we think we could work on it to make it a little bit more simpler and a bit more user-friendly. But so basically what happens is, under the hood, is we fetch the module, and then we parse it. And if I add a module, I think I've already added this one. Let me go for a different one. So I go for Core Lightning. Well, let's go for LND. Right, so I want to install LND, so I'm going to add it, and then I'm going to change some stuff. Oh. And I hear that Jonas Nick was complaining that there isn't a UI for Nix Bitcoin yet, so I'm glad we got there. So then if I update that, what happens is it just creates a simple JSON config file. So if I go to Nix here, oh no, wait there. No, wait there. If I go to config here, oh yeah, there's LND. And it creates this simple JSON config file, which then it will convert into your Nix Bitcoin config file. So you can run those applications and then rebuild your system and have access to those applications. So it's going from module to JSON, well, module to UI, creates the JSON, and then builds the Nix config file. But what it means for us is through just like a couple of UI files, basically, is someone can install LND, or they can install Core Lightning, or they can install any package which exists on Nix Bitcoin and can manage it from this UI. Yeah, they don't have to like touch that configuration file. It makes it a lot easier for them. So I think that's pretty cool. Other things we want to add as well, so obviously we've got this extra admin functionality, is if we install something like Core Lightning and then we go to install something like Core Lightning plugins, I mean, there's these amazing Core Lightning plugins, but there's no UI for them. I need a UI. If I'm installing Trusted Coin or something, which I want to run with my node, then I want to be able to access it via a UI as well. So I think it's important that in order to give more people access to Nix Bitcoin and have have more reproducible nodes and for their funds to be more secure, that having just a simple UI like this is a nice little addition, I believe. So that's basically it. I mean, that's pretty much what we've built. We're at the point now, I think tomorrow, where we're going to take that config file, so take that JSON and then turn it into the Nix configuration file. And then I think that the challenge tomorrow probably is to install LNbits through Nix and then install a package via the admin UI. Might be a bit ambitious. Another thing I'll be doing tomorrow, so a big part of LNbits is we have all these great hardware projects. We try and make Bitcoin as accessible and cheap for people as possible. So we have like a $10 hardware wallet, which we've built, and I've got like 10 of those. So tomorrow, if anyone wants to sit down and make a hardware wallet, then I can sit down and go through that with you. And I can give you a little example of the extension which we use for that. So we also have a Trezor integration as well, so you can use this to manage your funds on your Trezor wallet as well. But it's basically just a hardware wallet where you keeps your keys on your hardware wallet, and then we can create PSBTs and then send them to the hardware wallet, sign them, and then broadcast them from the software. What's the next slide on my presentation? Okay, I'll do that. So let's have a look at some extension shit, shall we? So as I said, for those of you who don't know LNbits, TPOS, that's a great extension where you can easily create a POS for a cafe or a bar. And then, so I could call this, cafe, create a wallet, connect it to an LNbits wallet, select a currency. You can even have tips. We can actually send the tips to a different wallet if we want to. for the staff, whoever was working at your bar. We can also, this is the update I wanted to show you in the POS extension, because this is new. It's got nothing to do with Nix, but I think it's kind of cool, is if I'm paying with Bitcoin, I had this problem when I was in El Salvador, I was paying in Bitcoin, and then I ran out of Bitcoin, I ran out of sats, and I'm like, I still want to pay in sats, but I haven't got any sats left. And I wanted to go into that shop, and then for them to sell me the Bitcoin back at a profit. So, like, we should enable these POSs for whoever is operating that POS and accumulating those sats to be able to then sell them back. I was just talking about the Bitcoin Jungle project, and I hear that they've onboarded a bunch of petrol stations, gas stations, and it would be cool. I want to be able to go into a gas station, and if the gas station lets me buy some Bitcoin off them. So yeah, we have this new function of being able to enable selling of Bitcoin, so we can enter like a maximum daily amount, and then a PIN in order to access that functionality in the POS, and then time between withdrawals as well. So just in case somebody gets the PIN to stop them from trying to take all your funds. This is entirely optional in the POS, but it then means that you get this little button here. So yeah, you can create a regular normal invoice for someone to pay. We've got an NFC functionality. If you're running on Chrome, you can use Web NFC to tap one of these great little NFC rings and make a payment, or one of the Bolt cards. But if we click on ATM here, and then I put my PIN, then I go into ATM mode, and then this isn't going to work because it's an LNUR withdrawal, and I'm running this locally, so I'm going to get an error. But what should happen is it brings up a LNUR withdrawal, and you can scan it, and then you'll get the funds off it. So yeah, it's one of those examples of all our extensions, like they're all separate projects on their own, and they could be extended and built on, and we could add more functionality to just the extensions themselves. Let's have a look at Streamer Copilot. That's the one I talked about before. So I'm going to show you the install process now. Oh, this is relevant, actually, to Nix, I think. I think that we could probably make these extensions modules. Oh, that's a shame, isn't it? We put in a big update with LNbits recently, so a couple of our extensions are being a bit, they need to be patched in order to work with the new update. LNUR devices, so this is the one which we use for points of sale, ATMs, and also this great project called the Bitcoin Switch project, which is you can turn anything on with Bitcoin. So if I open that up now, I can select whether I want to make a POS, an ATM. This is an offline POS or an offline ATM, by the way, or a Bitcoin Switch. And there's links to those different projects here on the side. So if we open up a couple of those, so we have the POS, here we go. So what have we got? So we've got the Bitcoin Switch project, turn anything on with Bitcoin. So for like £3, £4, you can create a little module which has a relay, and then you can turn on a motor in a vending machine, for example, and then just have a QR code on a vending machine and someone pays it, and then it'll turn the QR code on. Or you can use it for an arcade machine or a sweep machine. It's a great little project, simple code base. The Fossa, which is a free and open source ATM, we can just build a little Bitcoin ATM, and that uses this extension. This is completely offline. LNPOS. What's great about some of these projects we've got is we also have these online installers we've built as well. So when it comes to building something like a hardware wallet, you don't have to download Arduino or Platform.io and then compile and upload. You can just upload the binary from the web browser. So it's a very vibrant and exciting project. If I go to on-chain wallet, this is a thing we'll be doing tomorrow. And if I click on here, then it'll bring up the installer for the hardware wallet. As I said, we're always kind of breaking new ground when something, like I was involved in Nostar quite early on, so we had all these extensions sort of on the back boiler, but then when there was that Nostar renaissance, which happened over the past year, we were able to roll out some great Nostar extensions and great Nostar applications. We made the first sort of hardware signing device, so you can actually have your keys on a little microcontroller as opposed to having them in your web browser or on a phone or something. For those of you who don't know what Nostar is, and I'm just probably going over your head, and you should just research Nostar. It's a great project. So yeah, it's a very functional, fun project. Play around with it, install it for yourself. Go to the repo and install it for yourself. Obviously, there's a bunch of Nix people here now, and now we are Nixified, so it should be a lot easier to install via Nix, and then hopefully we'll get that in Nix Bitcoin soon. A big thanks to everyone who's been involved in helping Nixify, such as Pavel and Matt and a bunch of others. And yeah, I think that's pretty much it.
We've got 3 minutes for questions if anyone has any questions for Ben. Great, thanks a lot.
Cool. Oh yeah, grab me tomorrow if you want to make a hardware wallet, by the way.
Cool. Next up, we've got Matthew Crone, talking about how phones are computers. Cool.
It's all in shambles. Focus test. Get it down there, I don't know. So tiny. Not with me. This. That works. Okay, so this talk is called Phones Are Computers. It's going to be a hectic talk. So, phones are computers. They're the same as your laptop. And I really mean that, but the state doesn't want you to know that. They're keeping secrets from you. So first off, I'm going to introduce myself. I'm Matthew Krogan, and I run nix.how, which is a Nix software consultancy, and we just do anything, try to get paid for doing Nix. And I also run NixCamp, which we ran again this year, just a few days ago, and here's some pictures from that. We had a telepresence robot that we like to call the wheelie pad hanging out, and it is basically just an iPad on a stick with faces on it. And some people wanted their faces censored, so we used AI to do that, and we ran that AI with Nix. That's Max Headroom. He goes online by the alias Max Headroom. And here's Kranzes in his Nix lab coat, and there was like 24 people that showed up. So it's a cool event, and if you want to come next time, go to nix.camp and sign up early. So, phones are computers, but to understand that, we've got to understand where I began. So I met this guy. His name's Liam Kermos. He runs the Astral Ship, astralship.org. It's an old chapel in the middle of Wales. And here is a point cloud scan of it. So this was my office for basically, oh, well, that's disappointing, isn't it? I'm sure you can imagine an old chapel in the middle of Wales. Yeah. It's because I'm running on battery. Anyway, I'm sure you don't need to see that. You can imagine it. So, shortly after meeting that guy, I met this guy. That's Ben Ark. You may know him from 5 minutes ago. And I met him at CoinFest, and I tried to introduce him to Nix right there and then because this guy knew him. And I thought, you know, what better way to introduce myself to someone than talk about Nix? So I said, Nix is gluten-free, it's reproducible, you should be using it. And he basically just completely ignored me because he was busy. So, shortly afterwards, this guy says, we're going to EMF Camp, which is a nice little event in, I don't forget where, East Nor, looks like. And it's on again this year, and you should come along. It's just like CCC Camp and May Contain Hackers, MCH, camps like that. And that's where I encountered this beast. This is the Bitcoin beer tap, and it is the cheapest manner that I know of to attack Bitcoin. And it works. So people hang out around the tent and just get beers, get really drunk, and completely miss the point of Bitcoin. But it's a lot of fun. So at EMF Camp, I bumped into Ben Ark again, and I say, just try the goddamn Nix. Put on the goddamn glasses, man. And a few flakes, a few anarchist talks later, and a Raspberry Pi 400. And eventually I convinced him that this is a good idea. So he goes, do you want to come to Mallorca? So I head over to the Mallorca blockchain days, and Ben paid for it, and it was fantastic, and I met a bunch of lovely people there. And in the hotel room, I nixified LNbits, and he made this tweet about it. And it was on the Pi 400 there, that little keyboard computer, which I've still got with me, actually. Yeah. So I make this pull request, and here it is. You know, add Nix and poetry to the project. And it's a lot of waffle, but basically it just makes everything reproducible. But then, as Ben mentioned, it's reproducible, right? No. So the problem with just adding a flake to a project root is that people don't necessarily understand the maintenance cost of that, because they'll just say, okay, well, it's reproducible now. And then they'll add a really complicated C dependency or some native thing. And then it doesn't build anymore, and no one checks, no one cares, because they don't know what Nix is, and why should they, right? Because we haven't introduced it to them properly. But Nix does help, but it can't fix Python. So Python's the real underlying issue there, but it's gotten a lot better now because a lot less dependencies get added to the project over time, because it's kind of coming out of beta, becoming more stable, etc. And I mistook this for ignorance. I mistook this for people just not caring about Nix, but actually it's just because it's in development. So yeah, Nix will fail to help when you are inserting new dependencies every single day and you don't fully respect and understand the Nix. Like if you're not using Nix and you're adding a bunch of dependencies, the Nix is going to break, whereas your thing's not going to break because it works on your machine. Nix is a machine that works everywhere. And yeah, if you don't use that to test everything, then you're never going to know that it's broken. And that's indeed what happened. So Ben was like, I like that. It runs on the Raspberry Pi. So if he likes the Pi, what's he going to think of this? Boom. So I've got this phone here, and it runs NixOS completely, the same operating system that I'm running on the laptop, with no compromises. It runs everything exactly the same. And here it is with a more suitable keyboard. And yeah, your phone's a computer, believe it or not. So the phone only cost me £150, and it was released in 2018, and it has 10 gigabytes of RAM, and it's definitely not obsolete. I'm going to try and prove that to you. So now that we've got a phone that is actually a computer rather than just trash that runs Android, we can actually run all of the Bitcoin software. We can run all of Nix Bitcoin, and we can run LNbits on it. Well, here's a few use cases first. So there's the Nix phone plus the glasses. Now let me just go in here. I can show you a video of that. Phones are computers. Oh, that's the wrong thing. Oops. Yeah, so here is a preview from a video that I'm making. So these are some Nreal Air glasses, and you can put them on. And you can look around, and you can have terminals all around you. And it looks like this. right? And that is the future. The future is... The future is wearing a pair of glasses, going to work, and having no desks, and just standing there. And you can have keyboards on your thighs and stuff like that. But I mean, imagine a future where your Bitcoin wallet's like on your glasses, and if anyone comes to take it, you can just crunch the glasses with your fingers and it's all gone. It's interesting because like the size of computers actually makes a big difference in your life, I think. What else have I got to show off? Oh yeah, of course, because it's a computer, you can plug it into a monitor and just use it like a normal computer. And it is genuinely, in my view, just as powerful, if not more powerful than my laptop. So I hope you're all getting some ideas about how you can use this, because that's the point. So the piece of software that I just used to demonstrate like the multi-monitor experience in the glasses is called Stardust XR. It's a Rust program. Yeah, it's open source. You can find it on GitHub. So another novel use case is the head piecer when you're too poor to get one of those. And you can just put this phone in front of you and just use a Bluetooth mouse and keyboard, and that kind of works. It sucks, but it kind of works. And the key piecer, which is where you just got the keyboards and the glasses, and yeah. You can also run Windows 10 on it. Not that you would want to, but you can. And by the way, we can also run Android on top of NixOS. And that's no problem, and I'll demonstrate some of that. So now comes the demos. So I just want to explain to everyone what a NixOS configuration actually is. A NixOS configuration is when you describe your computer in terms of basic English. So this would be a flake.nix. Let's actually call it that so the language server takes effect. Right. So in a flake, you have inputs, which says what version of NixOS you want to use. And then you have some outputs. And one of the outputs is going to be anything that's passed in, Nix packages, that's it. And our NixOS configuration for my computer is as follows. It's a result of a function call. And it's going to be an x86 system like my laptop. And in it, we're going to have some modules or Nix files that we want to include. And what are we going to do? Well, we're going to just put it in here because I don't want to make another file. And this is the contents that the file would be if it was a file. Services.bitcoin.enable equals true. It's actually Bitcoin D. And that will enable the Bitcoin daemon. Well, because of what we've done with LNbits, we can just do this. And now we can say inputs.lnbits.url github lnbits/lnbits. Pop it into the outputs. And now we can say services.lnbits.enable equals true, and that will just work. I'm going to give a demo of that working later. But just so people understand the syntax of Nix, this is how simple it can be. Okay? What's next? LNbits on the phone. Can we ping the phone? We can ping the phone. Okay, so let's SSH into the phone. Let's become root. It's all a bit messy, but I'm just going to show you what the config looks like. So I have a folder called phone. It's got a configuration.nix in it. And we've got the LNbits API key, which you're not allowed to see. And we've got lnbits.nix. And we're just going to include those files in the config and do a NixOS rebuild switch. So what's in hosts phone lnbits.nix? That's it. So that's how we configure the lnbits. And if I do a NixOS rebuild switch now, like so, and I'm telling it not to use builders because I don't want it to go to the internet, I want it to do everything locally. And in a few moments, we're going to have LNbits on the phone, so you should get your Lightning wallet ready because I'm going to make an invoice. What have we got after that? Oh. On your laptop, to the phone? Yeah, I've just SSH'd into the phone. And everything I'm doing right now is on the phone. You can see here it's rebooting the phone. Well, not rebooting, but... What's that, sorry?
No, it didn't locally rebuild.
No, the phone built locally. It's running NixOS. It's the same as my laptop. All I did was a NixOS rebuild switch on the phone. And so now the phone has applied those changes that I just asked for. and I can go to phone 8231, and there's LNbits. So if anyone wants to connect to that and prove it to themselves, it's on the local network, and its IP address is that. If anyone wants to go to it, yeah, 202.209. So let's make a new wallet, blah wallet. And is it possible that if I create an invoice, someone can pay it using the QR code scanner? So let's say 20 Satoshis. $8231. See, I better get my talk over with quick before someone hacks it, Ben. Okay, so has anyone paid that yet? No, I do have a wallet. There we go, 20 sats. There it is. All right, that's all running on the phone. So I didn't actually have the time to set up my own Lightning Network daemon, but there's technically no reason we can't do it on the phone entirely. And with secure boot and other mechanisms, we could actually make it so you could have a secure point of sale that even if the point of sale was stolen, is completely inert, because by the time it powers off, you'll need to boot back in, full disk encryption, secure boot, etc. Yeah. So what else is next? Where have my slides gone? Llama on the phone. Okay, so let's SSH back into the phone again. And we're going to run some large language model stuff. Demo 1 Llama. It does take a while on the phone. So how do we do that? Well, we do a Nix build or a Nix shell on Llama CPP, which has already got a flake at the root of it, and now I can use it on the phone. Because with Nix, you write the expression for it, and it runs everywhere. Could even run on RISC-V. So let's run Llama. And you guys can all log into this as well, if you've still got the IP. It's going to be on port 8080. Phone 8080. So there's Llama CPP. So this is very slow, so I'm just going to let it happen in the background, and we'll see what it comes up with. Please insult Docker. My career depends on it. So I'll just see what it comes up with. We'll be back in a minute. It's like sending an email to my phone. So yesterday I got a foot infection, or at least I thought I did, so I went to the hospital and waited 10 hours. And I installed Nix on Droid because why not, right? And the hospital had good Wi-Fi, and I was working on getting LNbits working on the Nix phone, but also on Android. So Nix on Droid is an Android app that you can install, and you can use Nix on it. And this is what the result looked like. Here's my laptop, and on the bottom left is my Android phone running Nix on Droid, and on the right is the real Nix phone running real NixOS. And they're all doing exactly the same thing. They're all running LNbits, right? So this is something, if anyone's got an old Android phone, they can use it for LNbits, which is my next slide. So the point of all of this is to say that old Android phones and phones that can run NixOS, they can all do exactly the same thing, and they're really ubiquitous. And they're like USB cables at this point, right? Like, you've got an old phone hanging out somewhere, so you can just spin up a point of sale. Yeah. Go wild. I'm going to do that. Okay. So I just wanted to show more of what the phone is capable of. So let's see if we can get rid of this. And you swipe from the top right. And turn the keyboard on, and now I'm using the phone. Okay, so it is just Neil Fetch. Yeah, it's NixOS on a 1+6T. Yeah, this thing's been up for 17 hours. And it's got, like I say, it's got 10 gigs of RAM. So yeah, very powerful stuff. So let's run Super Mario 64. This is actually a decompilation of Super Mario, so it's actually running natively on the phone. It's not an emulator, although the phone's perfectly capable of emulation and more. So let's kill that, and we can now maybe run. It's kind of hard without obscuring the phone. We can run Blender. So how many people knew phones were this powerful? So that's like a cube, so whatever. So let's run a more intensive thing. Like an Elko prism. Now, of course, I can run the Bitcoin daemon on this thing, but I've only got 256 gigabytes of disk space, but that'll change. And at that point, there's nothing stopping me. What, did we just crash Blender? That's disappointing, isn't it? I swear to God, it doesn't do that all the time. Yeah. Run FreeCAD. Run Basilisk. So, right. Oh crap, FreeCAD's starting up. That interface isn't very usable, is it? Let's launch a burn cycle game. Burn cycle's a cool game, who's heard of it? So yeah, phones are computers. Is anyone not convinced yet? Oh, I've got to kill it. Kill the basilisk. How do you do that? There we go, it's dead. This is what I meant by going crazy. DOSBox for all the Windows lovers. Yeah, got the same software installed on that. Oh, it's made a, oh God, it's really getting angry, isn't it? It says that Docker's an overhyped, poorly designed, bloated piece of software that's more trouble than it's worth. Does anyone agree with that? So it's like having a brand new sports car, but instead of driving it around, you just keep it in your garage and look at it. So yeah, my phone can make insults now. So yeah, this is all possible thanks to mobile.nixos.org, and a lot of work is inherited from post-MarketOS, who do the real kernel development that makes the hardware work correctly. And what about watches are computers? Because the author of Mobile NixOS got all of this working on a watch as well, so there is technically no reason that a smartwatch couldn't run a Bitcoin daemon as well, and Neutrino, and lots of other Bitcoin software. And if you actually want to run this, like as a personal device, this is the diff to my Flake, if anyone's familiar with Flakes already. I just add mobile NixOS and then define a phone with it down here. And it's then able to run all the same software that my laptop can with exactly the same set of expressions. And the desktop environment I'm using here is called SXMO, and it makes it usable as a phone. And Android, how do we do that? Oh, I haven't even gotten to that yet. Let's see if that works. So I'll just do Waydroid, show full UI, and see what happens. We'll see if that appears. But yeah, it's called Waydroid, and that's how we use it, just like that. And if we want to run LNbits, that's how we run LNbits. And if we want to run Bitcoin, that's how we do it. And if we want to run LND, that's how we do it, right? That's the goal, is to make it this simple and have a lot of inherited wisdom from the people who authored these modules and have them figure all of that out for us so that we can just enable it and get going. And there's Android. Yeah. Let's full screen that. So we got Android here running on the Nix phone. It's pretty smooth. We got F-Droid on Android running under NixOS. We can browse around. It's not the most exciting demo, this, is it? Oh yeah, the Godot game engine. I can run the Godot game engine on Android under NixOS, and that works. Right? And then I do that to get it back. Yeah, still a bit finicky, really. Oh no. Something else has gone wrong. Maybe it ran out of battery finally after 17 hours of uptime. Oh no, it's back. It's back. It was just the screen. Ah well, I'll give up at this point. Can't all go well. It's really went on about Docker, hasn't it? It just doesn't like it. It's like so yeah, your phone's a computer. It's more than enough for most people, and that's kind of my talk.
That's why the screen blank, by the way. It was pausing to take a deep breath before getting into the next part.
And this is when everyone
Like that
else
llama
goes
run.
around to spell a copy it needs.
All right, actually, I can show you, like, from scratch provisioning LNbits, right? And the way that we'll do that is I'll just SSH into my little service that I've made, where when you SSH in, it just spawns a VM straight away. And it'll attach us to a QEMU instance, and then we're NixOS, and we can play around and demonstrate things. There we go. Shell incoming in 3, 2, 1. Wow, it takes a long time to boot. Okay, there we go. So in etc NixOS, we've got our flake. And in that flake, we're going to have to add LNbits, but we don't have Vim. We're going to get Vim. And once we got Vim, we can then go ahead and express how we want to get LNbits from LNbits' own flake, and then create a system out of it just by using some Nix code. We're going to do a NixOS rebuild switch. Okay, so in the inputs, we're going to add LNbits, LNbits/LNbits, and then outputs, we're going to let LNbits into the system. And in our system, we're going to have a bunch of Nix files. One of those Nix files is going to come from LNbits. LNbits.nixos modules.default. The default NixOS module is being given to us by LNbits. And now that we have that, because of importing that, we can finally do services.lnbits.enable equals true. And now we can do a NixOS rebuild switch. And what we just asked for will become true. It will reproduce the whole thing. In the meantime, whilst this is deploying, has anyone got any questions?
I had one.
Yeah.
On your NixOS switch, you didn't have to specify -- flake.
That's because it's in etc NixOS. It picks flakes up from there automatically. It's just kind of an inherent default.
Okay.
Yeah. Any questions? Yeah.
Stupid question. Can you run Nix on Android on your Nix Android and then run Android again and Nix on Android again?
Yeah, absolutely. I think that will work just fine.
Wow.
However ridiculous it is. Of course, Android in that case is actually just running as a Linux process. It's not a VM or anything like that. It's actually running as a container inside of Linux. So everything runs almost better because it's using the host's kernel. It inherits the performance properties of that. Like, it gets better over time. Yeah.
I have a question. What's the name of the phone you are using?
It's a OnePlus 6, and it's from 2018, and it cost £100.
Yeah, that's amazing.
It is, and just imagine, and it's all part of the SDM845 chipset, which is a lot of phones. There's actually a whole class of phones that are just like this that can do everything that this phone can do. Yeah.
Because I remember playing with NixOS Mobile like 5 years ago, and there weren't just a lot of good phones. So that's great. And other question, you mentioned this these glasses thing. What are the specs of these?
They're like 1080p glasses, but I actually have them on me, so if anyone wants to try them out, you can.
Okay, thank you.
So still reproducing that LNbits there. There's a lot of Python dependencies. A lot.
So you said phones are computers, but what about iPhones? You didn't really mention anything about iPhones.
U-phones?
iPhones.
Right.
Yeah.
I mean, I know of one person running an i686 emulator on an iPhone, and that can run Nix. So there is a way to run Nix on the iPhone, but it's not great. Yeah.
Anyone else?
Could you use the SIM card, have cellular reception?
Yeah, all of that works. The only thing that doesn't work is the camera and NFC. But that's not going to be the case forever because people are working on it in the open source.
Could you also make phone calls without like SIP?
You can make phone calls, yeah. Another thing I thought about is that you can actually you could do IP over GSM, because if you've got two Nix phones, I could just give someone internet in America if I've got free calls, for example. Like I could just call them and then do like dial-up over that GSM connection because the clients are controlled. Yeah. That's a lot of dependencies, Ben.
For the device support, you mentioned that you're inheriting stuff from post-market, but the set of supported devices is smaller than what post-market supports. I guess what's the gap here? Or
Yeah, there is a gap. So there's a few phones which you can find out, mobile.nixos.org/devices, and then you can figure out what phones are supported. But porting them is not that hard if post-market OS already has them. And in fact, we kind of rely on that. We rely on post-market OS having support first before we even bother making a mobile NixOS thing work. Yeah. Has anyone pushed to LNbits in the past 2 hours? This might be why it's taken a while. Right, there we go then. So it's actually got to reproduce a lot of stuff, whereas previously it came from a cache. Yeah. So this may not finish before the talk's over, but you get the point. Once this is done, LNbits will be on the machine, and we can just go in and play with it. Yeah.
For all the Python dependencies, are you able to do fancy stuff like the intermediate caching?
So for Fedimint, because we use Rust, is that we can reuse all the intermediate caching and stuff when we're doing the builds? Can you do that with Python too, or?
Yeah, absolutely. I mean, so the problem here is that LNbits doesn't have a CI that caches everything, so we have to reproduce everything from scratch every time we do the nix command. But that's fixable. We just have to host that infrastructure to do that. Because right now it is sovereign. It's building everything from source, including some of the Python cryptography library, things like this, right, on this fresh VM. So what you're looking at right now is basically Gen 2. There's no cache happening. Yeah. All right, cool. I guess that's the talk then. And yeah.
One more question. One last question.
Yeah.
Your VM spawner, can the VMs share the same Nix store so that it kind of caches everything between them? Or
I'm working on that, but yeah, I don't think this one does, which is part of the reason that this isn't caching anything. Right, this is all fresh. So yeah, it's just a matter of configuration, but it can. Okay.
It's fun. Thank you. Cool. All right, up next we've got Eric talking about Nix as a cypherpunk tool.
Yeah.
Go, Eric.
Woo!
Sorry. Oh no, that's not mine. Should this work normally? Is this the right one?
Yeah, that's right. Can you extend your screen?
It's not even registered right now. Or I cannot see it. I will try to plug it in again.
It takes some time to sync once it's plugged in.
Can some more graphical tool. Nope.
While we have a quick minute, I just wanted to remind people, I think there's someone doing a Bitcoin run tonight at 6 o'clock. And they're meeting, I think, outside at 6. So if you wanted to go on, how long is the run? 5-kilometer run starting at 6. So if you got some coffee and a banana in you now, you'll be ready to run 5 kilometers at 6 p.m. Great. So we've got this talk by Eric is gonna, so we've got Eric's talk, and then we'll have one final talk after this by Peter, and then we'll be done for today. I can give more details later, but tomorrow we'll be starting, I believe, at 9:30, I think is what's on the agenda. Again, back here tomorrow morning. We've got one more workshop tomorrow morning. We'll be demoing how to build NixOS modules. So this is it when you've got your own software that you've written, and you want to make sure that it's easy to deploy onto Nix. On a NixOS system, you need to write it, like package it up as a module, basically. So we've got Timo who will be doing that as a workshop first thing tomorrow. After that is basically a hack day. I think there's a couple people that have some projects that they want to work on. I think Cody's going to be running a flakeathon where we try and take a list of projects and write NixOS flakes for them, or just write flakes for them in general, just Nix flakes. And I feel like Ben's got a hardware project tomorrow that if you want to build your own hardware wallet, he'll be here. If you've got other projects, so it's kind of, tomorrow's mostly like an unconference day. At the end of the day, we'll start doing presentations. So if you've worked on something, you want to show it off. We'll have presentations, I think, starting at like 4:30. Yeah, I think that's it. Do you guys need some more time? Yeah. Laptop switch, okay. About supposedly there's a Bitcoin light show tonight while I'm talking about later things happening on. Does anyone know about the Bitcoin show of lights thing happening today? I think someone was posting, maybe Jeff does. Jeff's gonna come talk to us about
what?
The light project. You know what I'm talking about, right? Yeah.
Yeah, so there's Festival of Lights going on in Berlin that's not Bitcoin related, but there's a group called Bitman who has done a projection on the ECB in Frankfurt, and they are doing a projection tonight. And as far as I know, it's at 8, and at U-Bahn Museumsinsel, the Museum Island, next, and I think it's going to be projected at one side of the castle, the Berliner Stadtschloss, which is on the other side of the Berlin Dome. So it's U-Bahnhof Museum Island, Museumsinsel at 8 o'clock. That's all the details I know. I think like they are Bitman on Twitter or X or whatever you call it. And I guess there's going to be a couple people, but it's more like a projection, and then you can hang out, and there's probably going to be a couple Bitcoiners. But it always looks cool in the pictures, so if you don't have any plans. And it's also like interesting, it's like a touristy area, so you're going to see some cool like Berlin stuff and some other lights, and I don't know. So yeah, that's happening tonight.
Your Instagram, for those of you who are here for the grams, there's a grammable potential, it sounds like, at 8 p.m. Cool. Great. All right, I think
I'm ready to go.
You guys are ready to go? All right, awesome.
This should work.
Perfect.
Okay. Yeah, I got it.
The what? View menu, second from the bottom. Slideshow. There you go. Cool.
Oh, awesome.
All right.
Thank you.
All right. Let's give it up for Eric and his Nix for Cypherpunk tool. Thanks.
Yeah, so I prepared this talk quite a while ago for Bitcoin Pizza Day and couldn't give it there, unfortunately. So now I'm a little bit intimidated because of the crowd here that I have in front of me. Because back then, I kind of just wanted to shill Nix to them, to make them all use it. And now we had such great content already, and you're basically all already Nix-pilled, I guess. So I will still give it a shot, and I think I have a few interesting bits here and there where someone might learn something new. But if not, it's at least an example of how Nix can really make a project work so much better. I will be mostly talking about how the Fediman project uses Nix and NixOS to be more effective, to make developer life easier. Yeah, and so let's get started. Nix as a cypherpunk tool. I think the most well-known quote about cypherpunks is that cypherpunks write code. So that will be a huge part of this presentation today.
But I also wanted to extend this, and because like only writing code isn't getting us anywhere. Like we are not living in the cypherpunk future if we're only writing code. We also need to compile it, and then we need to deploy it. So we'll be talking about these three things today. How Nix helps us write, compile, and deploy code. First to the writing. That's where like you come in. Developers, 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 developers. And to retain and to attract developers, it's a really crucial thing for open source projects because there aren't that many of us, and especially not that many that are willing to like spend their free time coding, hacking on open source software that doesn't give them back anything directly. It's like a purely ideological thing. So we cannot waste this resource. Like it's one of the scarcest things we have. So one of the big goals of Fediment is to make developer life as easy as possible when onboarding. And so what we don't want to do is this, like you have a whole document where you need to install a bunch of dependencies, then it might change your system. Now other things might fail because of that. And it's just like really intimidating. Like if you have ever tried to install a Bitcoin core from source, like it's really not that easy. Now you're compiling like some database from source because you need the right version, all this kind of stuff. When you compare it to how easy it can be with Nix, like you might not see it right now, but it's like literally only this one command you need to get started with developing Fediment. It's nix develop, and there you are. We're also using a very nice little tool called Just, which is essentially an updated version of Make. You might know the author. He came to fame recently with ordinals and inscriptions. It's also built by Casey. It's a really useful tool. In my opinion, a little bit more useful than ordinals, but opinions might differ on that one. Yeah, so basically you need one command to get into a developer environment, and then you have like all the tools that all the developers that came before you built for this project at your disposal. Like you see a few of them here. You can just build a project. You can like run checks and linters, all this kind of stuff. Then like another thing that's often hard to achieve for open source projects is that the tests that run in CI, in continuous integration, you might want to run them locally because you have a really nasty bug that you want to find, and like you cannot, like when it's only running in the cloud somewhere on GitHub Actions, like it's not easy to introspect what's actually happening. You don't have all the tools you have at your disposal locally. So what we can do with Nix actually is we can like specify our whole CI toolchain or our whole CI in Nix, and then only like what GitHub Action runs is the same as I could run locally. It's all encapsulated in the Nix build system. And for example, when you want to run all the CI tests for Fediment, you just call nix build if you want the logs, then -big L and hashtag CI.test.all. That's all you have to do. And I was actually lying when I said running it locally, because now you also have something really, really cool with Nix. You might not have the best machine for running tests at your hands right now, but you might have a big server in the cloud somewhere, but where you can log in, so you can attach a debugger and stuff like that. And Nix actually allows you to, with like these two further commands, say, okay, I kind of want to build this package, like the CI test package, but please do it on this machine there. And that machine might have like 64 cores and a lot of RAM, so it's going a lot faster. So that's all kind of, like all these are like little things that make developer life day to day so much more enjoyable. Then also, like you might not be only building like one application. Like for example, in the case of Fediment, we have our Fediment daemon, which is the server-side software, but we also build a Fediment client library, which can be used by end-user applications, like for example the Fedi app, or Webimint, which is the open source version that I'm building, to build client applications. And you don't want to reinvent the wheel.
Like, for example, for Webimint, I'm using nearly exactly the same developer environment as Fedimint by just importing it as like a flake input and just adding a very few, where is it? A few packages down here, like that are needed in addition to what Fedimint already needs. And I'm good to go. Like, that's the whole developer environment for Webimint. And like the biggest chunk, like over 1,000 lines of Nix, is still maintained by the Fedimint open source project. And this, my little weekend project, yeah, it doesn't have to worry about that. So, like the biggest part here, providing code, it makes onboarding new developers very, very easy. Like, you cannot have dependency conflicts between projects. Like, especially in the Python world, it can be rather annoying if you have like 2 projects using different versions of the same package, and then you need to decide what to install. And I know there are like all kinds of workarounds for that, but Nix is so much cleaner. Then you kind of get the same instructions for all the platforms. Like earlier, I think I only showed for how to get set up with Bitcoin, for compiling Bitcoin. I only showed the Ubuntu and Debian instructions. But then there's like Fedora-based operating systems, like Arch-based operating systems. Like all of them would have slightly different instructions that you need to maintain as like an open source project. And that's a lot of work. So with Nix, Nix can be installed on all of these different operating systems, even on Mac, even so there are some kinks there. And if you maintain like this one description of how to build and develop your project, then you cover them all. And yeah, lastly, you can also run the CI locally. I showed that. It does push a lot of complexity to the existing contributors of the project. That's something we experienced, but fortunately, we have some really OG Nix people on our team now, and they did some great work. I will be shilling like one of their projects at the end, which is basically the blueprint for what we're doing with Fedimint. And it assumes an existing Nix setup, which isn't a given. But the good thing about it is there's great documentation on how to set up like a really basic Nix environment. Like generally documentation in Nix isn't all that great, but for getting started, I think it's really good by now. Yeah, and I think that concludes the writing code part. But what about compiling? Like it's probably something that we spend a lot of time on. Like there is this xkcd for a reason. Like why are you slacking off again? I'm compiling my code. And so what is interesting about compiling? Like first of all, we talked about this already today, is not everyone wants to compile your software from source. So it takes a long time. Like for example, if I compile Fedimint from source on like a 8-core machine, it still takes like 5 to 7 minutes, I think, and I didn't time it recently. Like we sometimes make some improvements there, but it takes a long time. And if you do this for a lot of software, it becomes really annoying. So what you want is reproducibility so that someone can build the software for you. You can verify if you want to, and ideally you can find other people that already verified that for you, but then you can just use that artifact. And I think there was a great talk about TrustX this morning, which uses exactly that concept. Like multiple people build the same binary, and if you get the same outcome, then, I mean, maybe you don't need to build it yourself anymore. You just use what there's agreement on and consensus on. Actually, if you want to try this out, I'm not entirely sure if we're 100% reproducible. Like for x86, I got these hashes. Maybe try it out. It's the release version 0.1.1 from Fedimint. Yeah, if you have hashes for me, tell them. Okay, another interesting thing about compiling is not all our end users are Nix. Like, we might be able to convince all our developers to install Nix, but end users is a different topic. And so it's quite interesting that Nix lets you, without building a totally separate build instruction set, lets you generate Debian and RPM installation files. So you can now also use your same build instructions for
for targeting Debian and Fedora-based systems. And also, of course, like just building raw binaries. It's a little bit finicky at times, because what Nix is doing internally is essentially it packs up all the dependency it needs into like one binary, and at runtime it unpacks them. And it's not the nicest thing to do, I guess, but it works. So just because you're using Nix in your build pipeline doesn't mean your end users have to use Nix. And yeah, like for example, in our Fedimint CI, every time we push the master, we build these packages, and it's actually not that complicated. Like you can see, there is a flake for that, or like it's called a bundler. I don't know the exact intrinsics of it, but you basically tell Nix to use a specific bundler and then build a specific flake output, and it will generate a Debian or RPM file for you. So from an end user's perspective, it's quite simple if you don't run into any problems, which we sometimes do, but in the grand scheme, it's relatively straightforward to do. Then last but not least, cross-compiling is another issue, and at least from my perspective, Nix makes it much easier, because you don't have to install, like again, the cross-compilation toolchain globally, but rather whenever I want to do anything related to cross-compiling, I either go into a specific dev shell that's made for that, or I already have endpoints set up or flake output set up that do the cross-compiling for me. And that works quite well for us. Like it's also about reusability again. Like for example, if you're building a WASM blob in your CI already, then other people integrating with it don't have to do it. They just take that, or they can import like that flake output and use it for their applications they're building, which is quite convenient. Then the last part is the one that actually kind of inspired me for the talk title, like why Nix could be considered a cypherpunk tool. Because originally the title was kind of like to get into Parallel and nix-pill all these cypherpunks. So, but there's actually some truth to that, because as cypherpunks, we write code, yes, but if you have read the Cypherpunk manifesto, then in the same paragraph, it mentions something quite crucial. We don't care if you don't approve of the software we write. We know that software can't be destroyed, and that widely dispersed systems can't be shut down. Like that's exactly the way Bitcoin works. But it also encodes a different message. We are in conflict with an existing system. And as such, like we might be building open source code, because there, like everything is public, we can verify everything. But for example, if you're running an operation, like something where you do have operational secrets, then third parties become security holes. And since we're in conflict with an existing system, we cannot easily do what companies typically do. Companies just hire people that are experts in the specific fields. But if you're running something that the existing system doesn't agree with, then every single person you add to your operation becomes a security hole, a potential one. So what we need to do to be effective still, we need to empower the individual to have like all the knowledge of all these experts at its disposal. And I think that's where Nix can really shine. Like it doesn't do it everywhere yet, but it's a vision for the future, for what to build. One example where it already works really well, in my opinion, is like I remember setting up Nginx servers with certbot so I can get certificates from Let's Encrypt many times. It's very annoying. You're fiddling around with Nginx configs. You're setting up systemd services to keep like your certificates updated, and it requires a lot of intricate knowledge of like configuration file formats, of how these systems work.
And it just takes away mindshare that you could use for other things normally. With Nix, it's quite easy. Like, you see a service that I set up without SSL, and now it's with SSL. It's 2 lines, not more. So it's just one example, but it's, I think, a really powerful one. Like, if you never thought about how does certificate issuing work, how does configuring a web server work, then with this simple small template of Nix, you can get a web server that's secure with good defaults, with everything, because experts built this Nix module, which you can now easily reuse. And if we do the same for like all the relevant software, like we already have a great repository with Nix Bitcoin for the Bitcoin ecosystem, which comes with awesome security defaults, like with all the network namespacing and like what everyone should do, but nobody has time to learn this stuff. So that's why we need a language or a system like Nix that can encode this expert knowledge, where like a few like giga brains, like Jonas, like Eric Warstead, like sat down and built this amazing secure infrastructure, and now we as mere mortals can use it. And so everyone has their own like expert field. Like for example, if I build a Fedimint module, then it's much easier for me to do that than anyone else probably in this room. But then I can share it in a like reusable manner, which isn't possible, in my opinion, in any other way right now. Like, I've seen people share Ansible playbooks, but even there you're fiddling around, you're changing stuff. It's not easy to like give back. For example, if someone finds a problem with how Nix Bitcoin does stuff, then they can open PR, easily fix it. If someone publishes a random Ansible playbook and someone pulls it in, then it's not as easy to give back to them. At least in my experience with working with different kind of systems for systems management, it's quite unique to Nix. Another interesting feature that I use quite extensively, maybe because I'm working on weird software like Fedimint, where you always have to deploy, like for example, 4 instances of the same thing just to test out if it actually works. Because like if you're setting up a federation, then and it's a 3 out of 4 federation, you need 4 Guardian servers to test if, like, for example, your setup procedures work. And the cool thing about Nix is it's a functional language. So instead of building a specific system description, what I'm doing here in this example is I build a function called demo, which takes as input a host name, a hashed password, and an IP address, and then builds a whole system configuration, which is later deployed with Colmena, even though Carl mentioned it's probably not the best way to go about it. I might change that, but it works. And like instead of writing 4 system configurations and then copy-pasting different values in, I just have a function that generates these, and I give them the inputs it needs. And also related to like the previous point of sharing expert knowledge, I think I got these slides in the wrong order, is feature discoverability. Because now we have a formal description of configuration options. Like we don't have to learn 1,000 different arcane configuration file languages anymore. We have one, and it's easily discoverable. I think there's even a way to search for flake options, like for example, in Nix Bitcoin, which aren't in the official modules repository. But if you're looking for any service that you're trying to run, and you're not sure how you can configure it, then just taking a look at the official NixOS website and the options search will give you a great overview typically. And I think that's also quite important because you might not know all the options that exist for your software that you're trying to run. The last point that I actually I'm actually using and I want to make is that you're getting infrastructure as code here. Like when I'm deploying my services that I run, for example, recently like some forwarding broke and people couldn't join our Discord anymore, so I set up my own forwarding service. it's only a bit of code that I push, and that someone in theory could review. And that's actually pretty cool. And we'll get to that in a moment. Because if we have infrastructure or like services that we run as code, then we can suddenly have teams of admins, basically, that where no single admin can take over the entire system anymore. Like instead, what we can do is all of them review the changes we want to make to our deployed system and approve them. I actually heard a very interesting, similar idea years ago by Jonathan Logan, aka Smuggler, who is like in the cypherpunk community around Paralelnipolis. He's active there and also in Berlin. But he had the idea, and I'm not sure if it was ever implemented, that for managing systems, you would have a mirrored SSH session. And like every time one of the admins enters a command, then the other one has to acknowledge it and approve it. But if we can get away from this instruction-based management of our systems and move to one that's more descriptive, then I think just having a typical GitHub review process or a general like self-hosted Git review process is so much more powerful, because you can also just try out the changes locally, like Jonas showed with nix-Bitcoin. Like just run the entire setup or the entire nix-Bitcoin instance locally and test if all your continuous integration tests still work. Also, if you're working in a hostile environment, you might need to switch servers quite often. Like I read in like a description for how to run hidden services long-term that you should be switching your servers quite often if you're getting a lot of incoming traffic, because Tor isn't that secure anymore. And if you're a well-frequented site for reasons that we don't want to go into any further, then you're probably switching servers quite often, and it's quite a hassle. And with Nix, it can be so easy. Like you just upload your flake.nix, call nix rebuild switch, and there you go. You have a new server with exactly the same configuration, maybe migrating some state. And yeah, if we take this to an extreme, then maybe eventually we can get to a state where we have a service that notices, okay, I have like 10 instances of myself running. One of them just got taken down. Hey, I just spawned a new one. If we get parametric and electronically payable, like for example via Lightning hosting solutions, then we could build software that self-deploys, self-replicates, and is basically a living organism. And maybe even rewrites itself if we get far along with LLMs. And if LLMs understand Nix code, which I hope they will do eventually, then we could have software that just lives. And I think it would be a beautiful thing. You might be thinking, okay, that's already possible. And I would agree. We can kind of do a lot of that stuff with existing solutions like Ansible, but come on, why not do it right this time around? Like, say no to Ansible. And someone please make a sticker. I only took a photo of someone else's laptop where the sticker was. I couldn't find it online. If anyone knows where I can get the sticker, please tell me. Yeah, that's pretty much all I had to talk to you about. And there's one more thing I really want to shill, because we're all standing on the shoulders of giants. And in Fediman's case, it's DPC who couldn't be here, unfortunately. He's based in the US, so it's a long trip. But he is building this really awesome GitHub project called Rust Shop, which is basically a blueprint for how you would set up a new company that totally is based on Rust, on Nix, on all these great things. He recently released something called Flakebox, where you can set up your whole build environment in a flakified way. Definitely check it out. It's an awesome like repository of his ideas and like just general best practices on how to use Nix.
And yeah, he has introduced a lot of the great stuff we're using today in Fedimint. So big shout out to him. And yeah, that's why you should use Nix. And you can find my slides here. If we have time for any questions, I'm happy to answer them.
Anyone? Any questions?
How do I work for Fedimint? You use Nix a lot, right? So how do I work for Fedimint? Because it seems like a great place.
I mean, just join the project. It's an open source project. Come and join us. Oh.
Yeah, I can add a couple things. So you guys can go to https:/clover.app/instant/Fedimint, and that will spin up it'll spin up a VPS with the Nix Docker image, and it'll run Nix develop and have VS Code on there. And so it'll spin up just in your browser a VS Code attached to a VPS running our Fedimint Nix Flake, right? And so that's the fastest way to get started on developing on the project. And then tomorrow, because DPC can't be here, I'm going to go through his workshop of how to do Flakebox, right? And so that's all of our Rust tooling and Nix tooling that he pulled out, and just like so we're just going to like make a new like cargo new, and then just flakify it, and then start adding some like complex dependencies and stuff to it. And we do, for Fedimint, we do developer calls on Mondays at, 4 p.m. UTC, right?
I think it's like 6 Central European time, so probably 4 UTC.
Yeah, it's 9 a.m. Pacific time. I know that. Right. Yeah, so we do that on Mondays, and then Thursdays we do that, and we normally do deep dives on Thursdays, and the last like 3 weeks of deep dives have just been on like Nix Flakes, right? And so it's like an hour with like guys like Eric, DPC, guys who like know what they're doing. And so definitely come to those.
Cool. Thanks, Eric.
Awesome. Thank you.
All right, for our last talk of the day, we've got, hang on. Is it?
We hope that 30% battery life will be enough. Then it's over. then it's yeah, but it's okay. It's okay. It's okay. 40% battery life left, and it should be okay. It's okay. But I need to do some this. So, yeah, Peter. Whatever you prefer. Okay, everybody, let's see how this works here. Yeah. Okay, that should give us our slides. Fine, perfect. So, maybe you got the hint that we already use Nix shell here. Okay, yeah, I'm be the last talk of the day. There's quite some overlap with the last talk, so I try to keep it quick, and we will dive a little bit into the Nix shell and what we can do with it for development environments, and all of this from the perspective of a like everyday or real life project that we work on. Yeah, okay, I got this picture from Tumblr there. I like it. And okay, a little bit background. I'm Peter, working at Blockstream in the Core Lightning team, and there I'm mostly working on Greenlight, and I'm also currently I'm the maintainer of the PeerSwap project, and that's where all of this talk originates from, or all that we will see today, is because we also use we use Nix there for our development environments and also our CI. Yeah, it works on my machine. That's a quote from an unknown software developer. I guess could be everyone. I guess everybody heard this quote before, and it's yeah, it's a horrible thing. It shows that or you typically say it if you don't know what's going wrong or why things are not going as you wish. And we may see or we may find out about how Nix can help us to avoid this sentence and to maybe never hear it again. Okay, yeah, that's a picture. Is it readable? Yeah, maybe a little bit. Let's go through some of them. That's the top 20 replies by programmers when the programs don't work. Yeah, and some of them are like, for example, number 18, it worked yesterday. Heard this before. How is that possible? Heard this before. It must be a hardware problem. Also heard this before. And some of them we might get rid of today. Okay, when we say it works on my machine, what are we talking about? It's mostly that we have software or code that behaves correctly or produces bugs on my machine, but not on other machines. And both is horrible. I mean, if it works on my machine, it doesn't work on a different machine, that's horrible. But also if it produces bugs on my machine, but not on a different machine, that's also horrible. And what can we do about it? And there comes Nix shell into play and Nix develop. And Eric already said something about Nix develop, and that's what we're going to dive into now. A little disclaimer, I'm not a Nix expert, so if you have any Nix questions, ask Matthew, for example. He runs a consultancy on Nix, so, so this talk will stay on a pretty high level, and we will just explore what the Nix shell can offer us for local development. It's based on the PeerSwap repository. It includes some live coding, so that could go horribly wrong. And it is basically 3 parts. We will start with a short explanation, then we will go through what is needed to write a flake for our Nix shell, and last part might be a little rant about Docker. Okay, what is PeerSwap? I don't know if you're familiar with the project. It's an atomic on-off-chain swap protocol. Sometimes people refer to it as submarine swaps. What we do is we enable Lightning nodes to swap Lightning liquidity to Bitcoin or to liquid Bitcoin. It comes with some executables. We have a plugin for Core Lightning, we have a standalone daemon for LND, and we have a command line interface also for the standalone daemon, and it's written in Golang. A little bit about this, so to explain what the project is about and also where the dependencies are coming from. So Go for is this, it should be clear, the program is written in Go. We also depend on Bitcoin for integration tests, same as with Elements-D. Also, we rely on Core Lightning for integration tests and cross-implementation tests. And there are 2 flavors, one with developer flags enabled and one without. LND, OpenSSL for certificate stuff, Bolt browser to inspect the Bolt DB, and Go tools, I have no clue what these do, but they are also there. JQ to make our lives a little bit easier. Mermaid CLI to produce beautiful state diagrams from our state machine. And then a whole bunch of protobuf stuff. And all of these have versions. And that's bad. Here are some real-life examples of how, for example, if you have different versions of protobuf on Protalk, the compiler, I don't know if you're familiar with it, but it changes quite often, and most of the changes are bike shedding changes. It's like as you see in the bottom lines, it just changes some naming stuff. And if now I have one version and my co-developer has another version, then we will have these kind of commits back and forth, and it will never stop, and it's just annoying. Also, APIs can change through versions. Top example is a quite heavy one from Core Lightning. I don't know when this was introduced, 2305 or something, I don't know, but it was called the Great MSAT Purge, and it broke quite a lot of applications. Also behavior can change. The lower example is from LND, where a channel update without max HTLC message flags that are now recognized as invalid and are not relayed. So these things can happen that they fail on one machine but not on the other if we have version drifts under our developer team or something. And also, yeah, CI fails, but it works on my machine. That's always good. Okay, Nix shell is here for the rescue. And what is the Nix shell? It's an environment created by the Nix package manager, but please correct me if I'm wrong on anything about this. I'm not, as I said, I'm not a Nix expert. Yeah. And it can be spawned and contain Nix packages, and so we get access to these Nix packages. It basically just manipulates the path, the environmental variable for the path, and it can be used to create isolated and reproducible environments. And now the fun part begins. We start to demo something. Okay, Okay, for example, let's say I want to say Cashew, hello Berlin. I don't have Cashew installed. So what can we do about it? We can say, oh, I copied it already, didn't I? Yeah. We just spawn a shell with it. And if we run it again, oh, what's happening here? Cashew, hello Berlin. And now it works. We just have it here. We close our shell, we try it again, and it's gone. So we may also want to have a deeper look on what is happening there. So what we can see is that Cashew points now to path in the Nix store, and all this number stuff here, that's responsible for giving us the so-called reproducibility. It's a hash that's based on the inputs of a derivation and stuff like this. So that's basically the thing that's under the hood is like giving us the reproducibility, heavy word. We also could explore, I don't know if this is a good idea to do this, but let's say, yeah, we can see there's a whole lot of stuff of Nix added to a path variable. That's what basically going on there. Okay, oh, now we have to click in this again. Okay, yeah, I find this is pretty amazing. We can open a shell, we have a program, and we close it and it's gone. I mean, come on, it is amazing. Okay, back to peer swap. What do we want for our project? We want the same Go version across all developer environments and also for the CI. We want to run integration cross-implementation tests locally and on CI. We want to experiment with LND and Core Lightning locally. We want to build documentation, generated stuff. We want to compile proto in the stuff, and we want to debug the database. And we also want to keep our own shell, and we don't want to use anything else because we like our shiny shells. And what we do not want is any of the dependencies to bleed into our host system, into our own system. Okay, let's check on these. Did we exit the shell yet? No. Okay. No, should. Okay, if we now run, for example, make all docs, that's what building the documentation background, it doesn't work because it says it does need some program that's called MMDC, and it doesn't work. Okay, same here again. We can just, what is this, mermaid, how is it called? I have to copy it from here. We can open a shell that contains our development dependency, and now we can build the documentation, and now it works. Yeah. So we could call it a day and say, okay, that's it. We don't need anything more. We could just add all of these up in this kind of like command, and we start our shell and we call it a day. But that is rather painful. So we can use a flake to do this for us, or to keep this organized, so to say. Short reminder about the flakes. Oh, there's a whole lot of stuff that's standing here. That's from the official documentation. I highlighted the stuff that's interesting for us, and that is it's new, it's experimental, and it's also super fast. So that's enough arguments. We use it. And as a short reminder, a flake is a set that has inputs and outputs, and the inputs are basically dependencies, and the outputs could be multiple outputs. Could be packages, templates, configuration, or also environments, and that's what we are going to use it for. And also, Flake comes with a log file, so if you build it, or if you open the shell, or if you interact with it from the Nix commands, it will produce a log file that is also saving reproducibility, or giving us reproducibility. Okay, this is how something like an easy version, or in contain, or how to say, like a yeah, what the flake can look like. We can go through it step by step. First line here is loading the Nix packages as an input. Second line is loading the flake utils as an input. That's some kind of helper functions that help us to deal with the kind of system things that are under the hood. Like here we call it with it gives us the system argument, and we can inherit a system so that we can build it for different architectures. That's not. But we don't have to understand this. And that's the important part, or the fun part is starting here. We can say, I cannot really highlight this. We can say, we want to spawn a dev shell. We use the make shell call for this, and we can give it some packages that it should contain. And that's something that we can, let's give it a try. So this is the flake.nix file. We save it, we run it. I'm still in a shell here. Something went wrong. By accident, totally by accident. And you can see that the tool is also pretty helpful to us and is trying to help us to write the right code. And obviously there's been typo, so it even tells me what I should have done. So let's do that. What was an M here, wasn't it? Yeah. Okay, let's do this again. And we are in the shell. Now what did we give it? We give it Cashew also. Let's check if this works. It works. Okay, Cashew is pretty useless, but we could now give it all the dependencies that we specified in the beginning that we need for this program or for our project. How was the code block? It was with the dev shells, was everything. Okay, exit the shell, enter the shell. It's evaluating. I luckily got all cached, so it didn't take that long. And now we can see if we, for example, check on which versions we are using for Go. It is Go 119, the one that we specified in the build inputs. I'm not really sure why they make this, why they distinguish between build inputs and packages. That might be questioned for some expert, but basically they use all the fields or attributes that you also have when you make derivations, more or less. Okay, yeah. I mean that's more or less what we want. One further thing that we wanted was to have a core lightning in two different flavors, one with the developer flags enabled and one without. And luckily, derivations can be overridden. So it's called overridables, and derivations are overridables, and we can use a command that's called override derivation to basically override the build process of our derivation or of our package that we load there. We can see it here. First I put it into code, and then we can go through it a little bit. Packages, I guess it should go here, somewhere here. Yeah, seems fine. Okay, what it does is it gets some attributes, and then we can override the attributes of a derivation. In our case, we add the configure flags, enable developer, and we give it a different name so that we can distinguish it from the original version. And then we also have to add it to our packages. And we may also want to make it usable by our tests, and we define some variables, some environmental variables for this. This can also easily be done with the shell, with something called the shell hook, that is basically something that is called when we start our shell. So on startup, the shell hook is called, which we will see with the echo line also there. So am I still in the shell? I am. I was. Okay, let's check on this. Develop. Oh no, it's downloading something. But yeah, here's what was dirty. The Git tree is dirty, yeah. But okay, this is building core lightning now in the back for us with the configure flag enabled. Let me try if I can speed this up a little bit by pinning to this version of the Nix packages, which is basically what we can do to ensure the versions, or to also have different versions. If we want to have Core Lightning version 23.05 and also in 23.08 or something, that could be done by pinning to the revision of the Nix packages repository. Did I copy the whole line? No, I should copy the whole line. Okay, now I did. And let's see if, I guess I pre-built this one, and this should then be faster. Let's interrupt this here and start this again. Yeah, okay. I pre-built this one. Now we can, what did I call this? Lightning, something, lightning d_dev. So, and we can see that this is now, it also has, we changed the name, if we recall this, and it also has changed the name here. That's also something that I find pretty amazing. Let's go a little bit, let's also talk about this section here. What we do with the $ and the curly braces is Nix internally will look up where this package is stored, and then will print out the path to it. Okay, that's it. Back to peer swap. So we got same Go running on all machines, run integration cost, implementation test locally. We could show it that they take forever, but I can just show that they will start to run. So this builds the program, and yeah, now all the tests are running, but it's a bunch, and they take forever. Okay, we can experiment with LND and Core Lightning in our shell. As I showed, we could easily use LND now on the shell, even though we don't have it on the host system, or installed or usable in our host system, so to say. We can build a documentation, we showed that. We can compile proto and all of these stuff. We can debug the database. Still open that we keep our own shell. I don't know if you recognize or saw this, but this now we have a, how do you show this? Do you do it like this? Oh, yeah. We are running in a bash, and originally the system uses ZSH. C#. Okay, so that's also something that we want to have, so that we don't have that we don't even recognize that we are running in a Nix shell here, and it just feels like our home system. That's also astonishingly easy to do. We just have to use derenv. I don't know if maybe derenv is something that people know about. And derenv can, it basically what it does is it checks your working directory for a file that's called .envrc, and if it finds this, then it loads the subshell and makes the environmental variables given if this .envrc file available to the shell. So basically, it loads and unloads environmental variables, and it could also be used to drop us into a Nix shell by simply adding. Oh, I already done it here. Simply adding these two words and a dot. And how does this look like? Are we in a shell still? No, we haven't been. Damn. I will make this bigger again. Yeah, but you saw there's a whole bunch of things happening there. How do I make this bigger? Is it this one? Yeah. And basically, it just loaded a lot of environmental variables, and you can also see a whole bunch of Nix stuff that has been loaded there. And if we now check on which Go we are using the one that we set in our flake. So this is quite easy to use. I mean, I just have to enter my directory, and it's all set up for me automatically. Boom, next mind-blowing moment, for me at least. It's, yeah. Okay, we could now call it a day, but well, hello there. There are other options to maybe achieve something similar. First thing that might come to your mind is, why not use Docker? a whole lot of reasons, but I mean, yeah, if you've seen this on the left, they also try to claim that they fixed the "it works on my machine" problem. Let's check if this is true. We have here a whole bunch of articles, Medium articles that try to explain how Docker fixes this. Let's just check on the last one here. They also claim it, and luckily for us, they gave us a GitHub repository to show how it fixes this, and let's check if it really does. Not to blame the developer here. I mean, they did great work. Okay, so they have, it seems like, some JavaScript stuff with package JSON, package something. It is a log file here, so that's good for them. Let's check the Docker file. Okay, first line. From Ubuntu, what is that? So, I mean, I don't know if you already see why this is really problematic. Let's maybe ask Ubuntu to help us here and to explain to us what that means. And yeah, okay, they tell us what Ubuntu latest is, what Ubuntu rolling is, what Ubuntu Devil is, but what is just Ubuntu? I don't know. I don't have any idea what it is. So it could be latest, it could be an LTS version. We have no idea what kind of version this is loading. Okay, then they load a bunch of stuff. Oh, that's also, the layering is wrong. If somebody recognizes, you shouldn't copy the stuff before you update us. Yeah. Run update. Which version of NPM are they installing there? I have no clue. And they also don't have a clue. So what can happen is if two individual people are running this Docker file to create themselves an environment in which they build or experiment or develop, they can have completely different versions of NPM that they run. So I would say it doesn't fix the problem. And kill a whale. No, please don't, we love our whales. But there are a few reasons why Docker might not be the tool we are looking for. One is also privilege escalation with Docker. So basically, if you run Docker, you are running root. You could mount any kind of directory and work on it as if you were root without using sudo. I mean, you can set it up right way, but that's default mode, and that's not a good default mode. We don't get, or with Nix, we get guaranteed reproducibility in the Nix sense, what they mean with reproducibility. We haven't that much time dependencies as if we work with apt, for example, in Dockerfile, where we are highly time dependent on when we run this build script. And we can keep our own shiny shell and don't have to use like something that was set up for us there. We are also, Nix can also be used natively on Mac. I mean, Eric also said this, and it comes with some drawbacks, yeah, but it works. And finally, if you ship Docker, then please at least build your Docker files with Nix. That's also possible. Okay, bonus gig. Yeah, I just also wanted to point out that there are Nix actions. We can actually look at how we set up CI here. Oh no, that's wrong. Oh, yeah, please don't see that there's Docker stuff. Okay, we can set it up. We have action set up. Yeah. Oh no, wait. Yeah. We can even cache all the stuff that we do there, and we can just use the standard cache that Git gives us with a cache action, and just hash the files. Hash our, oh, this is an old version that still has the packages on Nix. Should then be the flake.nix. Store the stuff there. We can import the stuff from cache so that we don't have to build it up every time again. And basically, we just call nix shell run make test, and that's it. CI is set up, and it's running the same versions as we use locally across all machines. Then also I wanted to mention that there are tools. I mean, you already mentioned Nix cannot fix Python, but there are tools for to port your poultry stuff over to Nix and to move your Go mode stuff over to Nix. There are a whole lot of things that you can do with it to give yourself a better development environment. Okay, yeah, I guess we made it. I would call it a day for, yeah, and if you have any questions, please ask the experts. Good. No, but real, if there are any questions, I'm happy to answer, if I can.
Here. Was that repo that you showed of a Docker file, like it runs on my machine demo? Was that a real demo? I feel like it was like an ironic demo.
It is. This is an article that I found, and it claims that Docker fixes the "it works on my machine" problem with a link to this repository, and
it has that line from a bunch. I mean, I just feel like, yeah.
It was too easy, wasn't it, to show why this doesn't work? It was way too easy, but
yeah.
I mean,
well, I guess either way,
yeah.
Much appreciation to them.
I mean, maybe it was satire, but yeah. Okay. Oh. Yeah, you should answer your questions yourself.
I don't know if you know this, but if you run Docker,
yes.
it actually fixes the reproducibility issues.
Perfect. I mean, you basically do if you run it in CI on GitHub, don't you? I mean, aren't they based on Docker? Is it not Docker in Docker then already? But now we can run Nix in Docker. That's also done. Okay, yeah, thanks.
Thanks, everyone. We'll be back here starting at 10 a.m. tomorrow. I think the venue will open around, let's say, 9:30 tomorrow morning. Is there a time we have to be out of here tonight? Does anyone know? 6 p.m. Yeah. All right, so we've got, like, is that 5 minutes until we have to... 15 minutes. All right, 15 minutes to make friends, figure out who you're going to be hacking with tomorrow. If not, we'll be back here at 9 a.m. Thank you, everyone who presented today. Cool. See you guys tomorrow.
Thank you, Nifty.